audible to all of you?
Yes, sir, you're audible, sir.
Okay, so the today topic for this faculty development program from my side is machining of polymer composites modified by carbon nanomaterials. So before starting my presentation, I want to briefly introduce about my university, from where I am doing some research and academic activities in my university. So this one is the brief info about Madan Mohan Malviya University of Technology. It was established in the year 1962. So very old institute. After that, it was upgraded to university in the year 2015. So again, I am very thankful to NIT Manipur, all the organizing committee member, and whatever I am presenting here, that is the collaborative job of my research team, in which we have some students, some pass out student, and also some presently student pursuing their research and development work in the different area of mechanical engineering. And also I am very thankful to my research collaborator, from where I have received funding or and financial support. So I am very thankful to Ministry of Education, Ministry of Textiles, Council of Science and Technology Uttar Pradesh, and UP Pollution Control Board, and TICCUP 3. So this one is all about my periphery information. So whatever I am presenting here, that is job of my students, that is job of so it is collaborative job. So the today job is mainly based upon this machining of nano composites material. So here we have introduced some carbon based nano materials, in which there are numbers of nanomaterials in carbon family, in which we have carbon nano onions, carbon nano sheets, carbon nano rods, multi-wall carbon nanotubes, and there are numerous numbers of this carbon-based nanomaterials. So in this study, I have introduced, or I have modified this laminate composite. That is our main parent composite is CFRP, and we have modified the properties with the introduction or with the supplement of this GO, that is graphene oxide. So this one is brief info about the short summary of this overall presentation. So in this presentation, we have not only developed and we have not only machine, we have also developed the product from our nano composites, whatever we have developed in our laboratory, and we have also introduced the developed polymer nano composite to a well recognized ISO certified industry, and they have also accepted our polymer nano composites, and with the help of this industry institute mode, III mode, we have developed some cylindrical shape pipes, which can be used for this electricity purpose, and simply we can say that the electric pole pipes with the help of our materials. So as we all are very well known about this composites, and there are different types. So mainly composites are defined in the form in basically three forms. That is, on the basis of matrix, we have polymer matrix composite, ceramic matrix composite, and metal matrix composite. What my job is totally based upon this polymer based matrix. So here I have introduce this graphene oxide into this carbon fiber reinforced polymer. So before starting our this development procedure, so some brief info and some initial primary information about this composite. So we know that we have two phase in composite, primary phase and secondary phase. So primary is the our matrix phase, and secondary is the reinforcement phase. So overall role of the reinforcement is to provide the mechanical strength and overall properties improvement. So with the addition of this matrix and reinforcement, we have composite material. After that, this one is also further this classification based upon matrix. And similarly, we have on the basis of reinforcement, we have different types of further composite, that is on the behavior, on the size of this reinforcement. We have particulate reinforced composite, fiber reinforced composite, and structure composites. in the form of different layers. So this total study is mainly based upon this our carbon nanomaterial, and in addition to this we have in the form of fiber we have carbon fiber. So double supplement of the reinforcement phase is there. So for that purpose this is here we have developed the nano composite materials. As we all are very well known that we are surrounded by these polymers in day-to-day life, from morning to evening and from morning to night, we are surrounded by different types of polymer. In our hand, we have mobile. In our laptop is also made of this polymer material. So there are numbers of polymer materials. So due to this improved properties such as moisture resistance, corrosion resistance, and high strength to weight ratio, we have higher use of polymer. So in 21st century, this manufacturing industries are attracted towards this polymer composite. And another advanced feature of these materials is easy to shape in different complex and different types of slots is easily available with the help of this polymer materials. But further, there is need of some improved material, which is uh, which is higher than which consists of some higher properties than this normal laminates or normal fiber reinforced polymer. So for that purpose, several eminent scholars introduced the nanomaterials into this polymer matrix composite. So in that series, we have also performed our job. So nanomaterial have some advanced feature than this traditional composite material. So as I have told that carbon-based nanomaterials. So here is the brief info about this carbon-based nanomaterial in this PPT. So we have different dimensions of nanomaterial. So on the basis of dimension here, four different categories of carbon-based nanomaterial, that is CBN is drive here. So one is 0D, 1D, 2D, and 3D. So on the basis of dimension, here the nanomaterial is divided into different forms. So in that number of nanomaterials, I have used this graphene. Graphene is a single layer atom of these honeycomb structures. So the length of this C to C is about 0.142 nanometer. So it consists of very high efficiency in terms of this strength, stiffness, elasticity, and electrical conductivity. So another issue is the as we know that for the development of any types of product, we need some manufacturing process. Whatever I am saying that this is easy to mold and easy to shape, but further there is need of some primary machining process. So without machining process, the development of any product, we have different small parts product, and we have to assemble a structure. We have to assemble a product. So for that purpose, we need some machining process. In this machining or manufacturing process, we have drilling process, we have milling process. So whatever easy to mold material is there, but in manufacturing sector, still there is need of some traditional and non-traditional machining. So my job is mainly based upon this CNC drilling and CNC milling of this polymer nanocomposites. So as we know that in matrix we have used this carbon fiber and polymer epoxy is used as matrix here, and another reinforcement is graphene oxide is used in the present job. So as we know that in this machining of polymers, due to anisotropic nature and non-homogeneous nature of this polymer composites, some machining challenges is there. So in machining challenges, there are uh, different issues. For example, when we are performing this drilling operation, then the severe damage issue is there. That is the delaminates of this internal and external side layers. So am I audible to all of you? Hello?
Yes, sir. Audible, sir.
Okay. So thank you. So another issues is the fiber pullout is also a one destructive issue in this machining of this polymer composites and nano composites. So some of the defect which is induced during the drilling process is mentioned in this PPT. So burr formation is there, irregular forms of fiber pull-out is there. So these major issues are very challenging for this manufacturing sector. As delamination in a study, it has been observed that 60% of part refusal is there only due to delamination issue. So from that study, it is remarked that delamination is the major issue in the laminates drilling. So wherever the laminates form of structure is there, then the chance of delamination is very heavy in the manufacturing process. So this is responsible for very high number of refusal of manufacturing parts. So now uh, we have to reduce. It is not possible that 100% elimination of any types of defect. We can only control, we can only reduce the defect up to certain level. So for that purpose, we have introduced this nano material in this CFRP, that is carbon fiber reinforced polymer composites. And further, another method is the control of different types of varying process parameter. As we know that different types of process parameters are responsible for our output response. Whatever about our output response, it may be our surface roughness, it may be our MRR, that is material removal rate, it may be circularity error, it may be delamination. So various studies also demonstrated that the control of different types of varying process constant is also play a very important role for this uh, achievement of this desired response. So the control of varying process parameters. Now we have the issues of control of the single response, and we have issues of multiple response. So in our uh, next slide, I will show you the control of this single response and this multi response. So before going to this our control of varying process parameters, so some brief info about this drilling process is there. So in this PPT, it is shown that the tool is introduced into this job material. So this one is the basic principle of this drill process, where feed is applied from the top direction and tool is rotated. And from these tools, the in this drilling tool, the top edge portion, that is the front face of this tool, is touching this material which is to be drilled. So this design of cutting tool is also a important parameter, also important constant during this manufacturing process. And also the different types of this tool materials. So if we are assuming that tool is the tool which is used for this metallic alloys and metallic other types of materials, so it is also valid for this our polymer composite or simply composite material, then it is not correct. So tool which is used for this machining of metal and their alloys, it is not efficient for the machining of polymers, as different types of layers is also there, different types of fiber orientation. As overall, I want to conclude that the overall this design of this fiber and the different types of weaving style is also used in this fabrication process of composite material. So these are some manufacturing aspect of this polymer or this composite material is entirely different from this the aspect of metal and their alloys. So the tool is somehow different. So in this polymer composite machining, we are using the different types of CBN, that is cubic boron nitride tool, cemented carbide tool, and PCD tools, that is polycrystalline diamond. These are different types of tool material which are used, or their coating are used on this tool for the performance of this drilling operations. So another is the basic advantage and this use or industrial use or the development of different types of end products. So these are some basic properties of this composite material. So we all known about all these basic properties. So in the following point, these are the some different applications which is summarized in this PPT. So these polymers As we know that earlier the structures applications are mainly of developed from this metal and their alloy, but after some time in 21st century, the improvement that is the high strength is to weight ratio attracted the manufacturing sector to develop these structure application components. So in aerospace, aircraft, aeronautics, the most of the parts are this fabricated from this polymer materials. So in there is also some potential application in the field of this EMI, that is electromagnetic interface shielding, and some other use is also mentioned here. So this one is the pictorial view of this potential application of this polymer based composite material. So, as I have already told that we are surrounded by polymers. From our day-to-day routine life, we are surrounded by polymers, either in the form of our mobile, in the form of our pen, in the form of our laptop, in the form of our surrounded different types of product is there. So, we are surrounded by polymers. So, this shows the feasibility and higher application potential of this polymer matrix composite. So, before starting my presentation, I want to introduce something about that. What is the need of this machining of these polymers, and why polymers machining is important from industry and from research and from academia point of view. So, in this in this presentation, this presentation is totally divided into three phases. That is, primary phase mainly deals with the fabrication and characterization of this polymer nanocomposite. Then intermediate phase will deals with this machining efficiency issues, in which different types of damages is shown in my presentation. After that, and phase is mainly based upon this the control of process parameter, and that how to reduce this machining induced damages during the process of drilling and milling. So this is controlled with the help of varying process parameter, and also we have developed one very noble optimization technique. So I will show you in my last phase the different innovative optimization, multi-objective optimization module to control this varying process parameter. So this one is the process which I have used for this development process. So this PPT shows the development of this nanocomposite materials. So here this hand layer process is used for development. And there are also some other processes also there, such as vacuum assisted resin transfer molding, which is mentioned in this PPT. So VARTEM, in short, it is called as VARTEM. So VARTEM is also used for the development of this nanocomposite materials. So in our laboratories, we have introduced two emerging fabrication technique. One is hand layup. It is very traditional and very old, and it is also very cost effective and very useful technique. And another one is the VARTEM, that is resin transfer molding. So vacuum environment is developed here. After that, this vacuum environment, we have infused the mixture of this epoxy and hardener into the different laminates layers or different this matrix phases. After that, this PPT shows the different properties which is these experiments or these studies was performed by some eminent scholars. So in this series, we have this geo. Simply the reinforced material here is the geo, and matrix material is polyamide. And here this the two weight percentage introduced in this matrix space. So this study was performed by Coyne et al. So different studies shows the importance of this polymer materials and the importance of different types of reinforcement into the matrix phase. So here different types of nanomaterial and different matrix shows the importance of this polymer nanocomposite. Also, the results which is obtained in their studies, the tensile result or tensile strength and tensile modulus shows the application potential of this nanomaterials role in this matrix phase. So different studies was performed here. So these are some further more studies. So here GNP, that is graphene nanoplatelets and short carbon fibers are also used in polypropylene, and different, that is MWCNT is also used in this epoxy matrix. So after that, earlier aspect was related to totally development phase. After that, the machining of this polymer based composite and nanocomposite material. So earlier some studies was performed by Raj Mohan et al. And some other eminent scholars, and the findings shows that the process parameter, the varying process parameter or process constant such as feed rate and speed. These play a very important role during machining, and the imbalance supplement of these constant will tends to this the very less efficient response, which is responsible for overall quality and productivity of the developed product. So it is very necessary and it is very important to develop the desired response in a significant way, such as we have surface roughness, so it should be lower. We have MRR, it should be higher, and further we have different responses. That is the cutting force is also there, delamination is also there. So these play a very important role. So further, this machining of different types of nanomaterial introduced into this matrix phase composite material is here. So in this MWCNT addition into this CFRP shows that this force decreases with the addition of nanomaterial. Also, this delamination factor, which is also known as FD, it is lower at the outlet and surface roughness is lower with the inclusion or with the supplement of this MWCNT. So these, the finding of these studies importance of nanomaterial into this polymer matrix composite. So after that, first one was related to our development phase, literature review on development phase. Then the earlier two PPT was related to this machining aspect and the effect of process parameter on response. And this table 2.3, this shows importance of the optimization module for the control of process parameter and their role to generate the desired machining response. So here some gentlemen perform different types of optimization. Here GRA fuzzy, that is gray relation analysis, and fuzzy is also used by this Dr. Vasudevan. Similarly, in this series, there are number of optimization techniques. So here also Topsys and then similarity based GRA method is also used. And after that, not these are some optimization, multi-objective optimization module. But further, some of the scholars have also used this meta heuristic optimization algorithm. So in this, there are different types of meta heuristic techniques. So similarly here, artificial neural network is also used for this control of speed, feed, and depth of cut uh, to achieve the desired value of thrust and surface roughness by Tassaw and et al. So after reviewing this development phase and this machining phase and this optimization phase, so totally three phases is performed on the basis of earlier job. So from after observation, all the three aspect or the three phase, that is development phase, machining phase, and optimization phase, it has been observed that the delamination is a major machining challenges for the manufacturer of these polymers. Some other aspect or other challenges are fiber breakage or simply fiber pull out, and abrasion issues is also there, and debonding of matrix. So these are some challenges or these are some defect which is generated during this manufacturing process. But in all these defects, it has been also observed that the most severe defect is the delamination issue. So as I have told that it is responsible for 60% of the parts refusal in manufacturing and in the aircraft trade. So some this summary about the refusal of different components was performed in a study, which I have mentioned here at this 40 number reference. So also it has been observed that there is essential need of different types of nanomaterial supplement in these polymer matrix composite. Or also with the addition of these nanomaterial, it is also very important that how these varying process parameter are responsible for the control of different types of responses. So there is also extreme need of this optimization module. So it has been observed that number of scholars have controlled this MRR, surface roughness, force, circularity error, and different responses was significantly improve or significantly achieve their desired target value with the help of this desirability function analysis. Gray theory is also widely used. Topsis-based method, utility-based Taguchi method is also used here. But further, there is need of some advanced optimization modules having some less complex steps should be there. So for all that purpose, we have used one very innovative technique, that is combined compromise solution. In short, it is also known as COCOSO, that is COCOSO, combined compromise solution, in addition with this principal component analysis. As we all are known that if our response objective function is only single, then there is no issue of this conflicting response and this correlation between the response. But if there are more than one response, if let us suppose we have two or three response, let us suppose we have MRR, surface roughness, circularity error. So these are numbers of responses which is very useful during the investigative study. So most of the study assume that these responses are not correlated to each other. But in practical or when we are performing any types of experimental job, it is not possible that one response is not correlated or not depend upon this other response. So negligible response correlation theory is not valid for this experimental job or any types of manufacturing experiments. Another one, that if we are assuming that the response one response is not dependent upon other response, then it is not right. It is not feasible solution. And after that, another assumptions which is widely assumed in most of the studies, that uniform response weight. Let us suppose we have four number of responses: MRR, surface roughness, and delamination, and this cutting force, and that we are assuming that all four are responsible for 25% of this priority weight, then it is not a right solution. That uh, it is possible that surface roughness is more dominant in this drilling operation, but it may be less dominant in milling. So if we are assuming that all the response priority weight is uniform, then it is not a right and not a feasible solution. And such types of assumption which is mentioned in this PPT, that is zero response correlation and uniform response priority weight. So such types of assumptions will lead to this ambiguity, error, and inefficient solutions, inefficient output value function. So initially we have to in this presentation we have tried to eliminate both the traditional assumptions with the use of this principal component analysis. Another aspect is that it has been also observed that several types of nanomaterial are introduced in polymer matrix, but still there are some other dimensions: 1D, 2D, 0D, 3D. There are different dimensions of nanomaterial, and there are also some emerging chances that if we are introducing some different nanomaterial into this polymer or some other types of composite material, then it is possible uh, that the limitations which are available in this normally macro size reinforced composites So the limitations is could be eradicated with the use of these nanomaterials. So therefore, the the manufacturing aspect, the synthesis and development aspect is a potential area of research not only for these industries. It is also emerging area of research for this manufacturing sector and also for academia sector. So in that series, due to the importance of these materials, nanomaterials, so the different institutions are trying to um, develop some cost-effective and durable material in society interest. So our objective should be that we have to develop such type of material which should be cost-effective and which should be having very feasible in different aspect. So whatever our use, we have to try for the development of such type of materials. So in that series, polymers play a very important role. After that, as I have already introduced about the importance of these polymer materials. So for that purpose, so effective machining environment is play a very important role for the overall productivity issues. So if our manufacturing or machining environment is favorable means is what? Whatever we are trying to achieve, it should be available in a very less time with very less efforts and less raw materials. Then our productive system is favorable and productive system. So for that productive efficient machining environment, we have to use robust automation tools to control these process parameters. So here, this one is the basics about this presentation. So as I have already told that in 3 phases, I have performed this study: fabrication and characterization. After that, we have evaluate the machining efficiency by performing this drilling test. And after that, we have also developed the end product with the help of this industry institute interface mode, that is about prototype fabrication. After that, last one is the future and the limitation of the present job. So this one is the basic properties of this nanomaterial, whatever I have used in the form of graphene. And these are some basic properties of this fiber. That is macro size fiber, what we have used, carbon fiber. So these are some basic properties. And then here, these are the properties of this epoxy. We have used as a matrix and some properties of hardener is mentioned here. So this one is the brief information about the fabrication procedure. So we have varied this nanomaterial into 3 different percentage. That is 1%, 2%, and 3%. We have taken this nanomaterial and disperse into this acetone solution. And this one is the information about this hand layer process. So this one is the fiber and resin ratio, 70:30 we have used here, and different layers that the size of layer is also mentioned here, and thickness of this fiber is 0.45 millimeter. This one is the brief or initial about the different vintage, that 2 and 3 weightage into this matrix, and 10:1 is the epoxy to hardener ratio. There are some images, laboratory images, which I have taken during the fabrication process. So in A to F, this shows the process. So ultrasonicator is used here for this fabrication process. So these are the images of the developed sample in 1, 2, and 3 weight percentages. We have developed this sample. After the development of this nanomaterial, we have also performed this morphology of nanomaterials, which we have performed in on BBAU University. So the uniform dispersion or the distribution of this nanomaterial into the epoxy and reinforcement material is observed in our developed sample, and this uniform dispersion and distribution will be responsible for improved mechanical properties. So we have also performed some test, that is tensile test and flexural, and other test is performed in my next PPTs. So this one is the SAM analysis of this modified epoxy. So these are some advanced characterization which we perform with the help of this IIT Kanpur. So these are the some XRD images at different weight percentage. So three types of sample is developed here, 1, 2, and 3. So the images are mentioned here. Further, some advancement of results of this versus temperature. These character for with true temperature is also performed here. So these are the sample sizes as per ASTM standard, which we have size or which we have developed for this tensile test and flexural test. So as per ASTM standard D3039 and D790, we have performed this our tensile test and flexural test. So these are the images of the these specimen. So after that, we have performed this testing of developed samples. So these are the results of tensile properties. So this plot shows two values, load and displacement, and it has been observed that the red one line shows the one weight percentage sample is withstand at very high load. Similarly, these are the images of tensile strength and tensile modulus. Here it has been observed that one weight percentage of this geo shows very efficient properties of this tensile and modulus. These are further some images for this flexural strength and flexural modulus. Are the images after of the sample in this tensile flexural test. So these images shows after performing the test and flexural test. This first one image in tensile breakage. Here the fiber breakage is shown in this PPT. So and this upper part shows that before this fiber breakage, the sample was subjected to tension. So images of this tensile test is shown here. After that, we have performed the SAM analysis of this tensile and flexural test. So SAM analysis of the broken or fracture part shows the internal changes in the fibers in the matrix. So here fiber pull out is observed, and the enlarged view of this one weight percentage, that is second number images. So from second number images, it is observed that matrix failure is there in tensile test, and the images shows the fiber pull out. After zooming this one weight percentage of this geo nanomaterial, it is observed that fiber pull out is there. So this one is the microstructure analysis of tensile test specimen. Then similarly, we have a microstructure analysis for flexural test. So this one is mainly performed to analyze the fiber breakage or to analyze the fiber pullout and matrix debonding, which is takes place during this tensile fracture and this flexural point fracture. After that, after studying this mechanical testing, it has been observed that the results which we have achieved at one weight percentage, that is one weight percentage of our addition, improve the tensile and flexural properties in a very significant way other than the different weight percentage of geo. And then we have also performed this drilling operation. So the machine which is used for this drilling, that is CNC drilling machine, the model number is BMB35TC20. And here we have also computed the force during this machining process with the help of this dynamometer. So this second image shows the enlarged view of this tool and this job, that is our material which is to be machined. And third image shows the geometry of this tool, that is the drill tool. So this third one image shows the brief information about this drill tool. So for these are the brief technical specification about the machine and different types of apparatus which I have used for the measurement of surface roughness. For the measurement of force, we have used this dynamometer. So this one is the force measurement, thrust and torque force measurement, and then after that we have performed this surface roughness measurement setup. Then after this surface roughness and this force in the form of thrust and torque, we have also investigated the delamination aspect, delamination at entry and delamination at exit with the help of this vision setup. High resolution vision setup we have used for the study of these images. We have obtained with the help of this vision setup, and with the help of MATLAB we have estimated the delamination aspect. So these are the images which we have obtained from this vision setup for the estimation of delamination factor. So these are after this delamination, we have analyzed the circularity error. That is the diameter defect during the drilling process. So the variation of this distance from this nominal diameter to the maximum diameter, or simply we say that the radius, maximum radius and this nominal radius. This one shows the circularity error. So this one is the image of drilled hole at entry side and drill hole at exit side, inlet and outlet. So this one is the image of this drilling of the samples. So here it has been observed that few sample have some damages such as fiber pull out, uncut fiber is also there, fiber fiber burning is also there. So these are some defects. For example, in this image in first side, delamination at entry, and in third row, some fibers is observed there, which is not machined during the drilling process. So some fiber is also observed, which is not machined during the drilling process. So this one is the machinability aspect and the effect of this thrust force and the different levels of speed, feed and depth of cut. So this one shows the effect of process parameter on one by one on responses. So here we have thrust, torque and surface roughness. After that, this one shows the SAM analysis of this drilled hole. In drilled surface, we have observed the surface morphology of the drilled hole or the machined surface. After observing the machined surface of the drilling process at this speed, it has been observed that at one weight percentage, first one is the at one weight percentage, then 2 weight percentage, then 3 weight percentage. So in 1 weight percentage, there are some matrix region, and in 2 weight percentage, there are some drilling induced damages in the form of voids, in the form of fiber breakage. So this shows the surface morphology of the machine surface. And then we have statically analyzed this response, that the effect of each varying process parameter on the response. So this one is the analysis of variance for this thrust force. So this is variance analysis for other factors, for delamination in, delamination out, and for the surface roughness. So we have this variance analysis to identify the significant factor or the importance of the factor, that which one is more dominant on the response. So different response have the effect of process parameters. So we have investigated the number of responses, that is, we have investigated the force and delamination at entry, delamination at exit, surface roughness, and circularity error. After that, this variance analysis, we have develop this regression analysis with the help of this response surface methodology. So this one is the statical analysis and probability plot, the residual effect, which shows a linear structure of all the points, all the data which is fitted with this line. This shows the adequacy of the performed experiment. So after that, the statical analysis of all the varying process parameter. Now, for a single response, which parameter is important, which constant is important, it is performed with the help of this variance analysis, and we have also draw different plots for this process parameter and their effect on this output values or our objective function. So this one is the single response analysis. Now this study also deals with the uh, two and more response, that is multi response, or simply some authors says the multi objective optimization process. So here we have used this innovative technique, which is very recently developed by Professor Yazdani et al. In the year. So initially it was used to determine the multiple criteria effect for the issue of supply chain management in France. So it is very novel optimization methodology, very novel optimization procedure, which is used for this multiple response or the aggregation of this multiple response. So following are some steps or the mathematical analysis of this process. Here, this one. So these are some steps. Initially, the normalization of the data, and then formation of this SI and PI. SI is total weight comparability sequence, and this PI, complete comparability weight, is mentioned by this equation number 14 and 15. So this one is the relative weights, which is defined with the help of these equations number 16, 17, 18. And finally, the overall this function value. Then before introducing this procedure of this combined compromise solution, we have introduced another statical technique, that is PCA. So it is a very important statical tool which is widely used to investigate the effect of one response over other response, and what is the percentage contribution of one response on overall objective function value. So here we have also explored this PCA. Before the development of our objective function, we have analyzed this response with the help of this PCA, that is principal component analysis tool. So this one is the overall methodology which we have proposed in the present job. So initially, the first phase is the methodology which is used for the performing the experimentation, machining experimentation. After that, we have introduced this PCA phase into the this combined compromise solution. And finally, third one is the hybridization of both the phases. And finally, we have achieved the objective function value or the optimal setting of objective function value. Further, we have validate the setting whatever we have achieved. It should be experimentally verified. So further, we have performed the test experiment. From that, we have the of our set we have achieved it, how much it is valid. So this one is the part of this proposed hybrid optimization module. So here these are the various parameter which I have used, and here the three level of variation is used for this process parameter. So speed, feed rate, and this weight percentage. So after that, we have used this response surface methodology, that is box Vengen design, to perform this 15 number of experiment. And correspondingly, we have observed the data in this PPT for the surface roughness and other circularity issues. So this one is the normalization procedure. So normalization is a very important steps in any types of data analysis. As we know that different response have different behavior. Someone need higher is better, someone need is lower is better. Someone had some unit and another have some different unit. So to get rid of all the conflicting nature, all the different behavior of the response, we have changed all the response value in between to 0 to 1. So the conversion of all the values, response values in between 0 to 1 is known as normalization of the data. So after normalization, we have introduced this PCA method. Here, this shows the contribution percentage. So this RA is 0.137, means this is what 1 point, 13.7 percentage contribution. For that, we have the position of all the values, whatever we have achieved in a ascending order. So here experimental number 2 have this highest value of the objective function. So this shows this optimal setting by this hybrid optimization module is mentioned here, and this values shows the optimal setting. So here orthogonal condition is mentioned and then optimal condition is mentioned. Then we have performed the confirmatory test on this optimal setting. So here it has been observed that the roughness value is improved. It means improve means it is lower the better. So this one is 1.80 in orthogonal, and in optimal it is 1.72, and after that it is 1.55. So lower value is desired for this surface roughness, and similarly for other responses. So it has been observed that this results of this hybrid optimization module shows the feasibility of this proposed optimization module, that the output whatever we have achieved here, the surface roughness and the other responses, that is circularity error, these values are as per their desired criteria. And also in objective function value it should be higher. So it is 33.946 in this confirmatory test. So this one shows the importance and the feasibility of this hybrid optimization module. So this COCOSO is a very latest technique, and very earlier it was used in supply chain management issues, some business studies, some commercial studies, but it is very limitedly used in the manufacturing aspect, or in the area of machining it is very limitedly used. That's why we have planned to use this novel optimization module in my study in my drilling process study. So after that, the result shows the feasibility of this module. After this machining aspect, we have tried to develop some product. Am I audible to all of you?
Yes, sir, you're audible, sir.
So after that, this development phase is there. After this optimization module, we have developed some product with help of this industry institute interface. So the mechanical testing shows the feasibility of these proposed composite material. After this testing, we have performed the machining experimentation, and after machining experimentation, we have used the optimization module. So this one is the our academic activity or academic this phases of this develop material. That then further we from the industry point of view, we have developed some product with the help of one industry. So here I am very thankful to Messrs. Gen Fiber industrial area, which is available at Gorakhpur in India. It is an ISO certified industry. So with the help of this industry, we have produced the pipes which could be used for this electric pole pipes or some other similar use of this material, the developed material which we have developed in-house. So for that purpose, we have developed one electric pole pipes. So here it is observed that neat CFRP means there is no any addition of these nanomaterials. So only CFRP carbon fiber reinforced polymer composite and epoxy is here matrix. And in this data sheet, it is observed that tensile testing in uniaxial direction is what? 625.79. Tensile modulus is 8.644. Flexural properties is also there. After that, we have introduced our material, what we have developed in our laboratory. So this geo addition into this FRP is here. So the result is mentioned here. For one weight percentage, it is 934. For two, it is 788, and for three, 774. So here, our mechanical testing shows that one weight percentage is very feasible for this composite development. With the help of our testing, it is validated, and with the help of our machining aspect or our machining procedure, it is also validated that one weight percentage is very feasible. And after this development of product, further it shows the importance of this one weight percentage of graphene oxide and carbon fiber. Actually, the higher addition of this weight percentage leads to the tendency of agglomeration or the accumulation of these nanomaterials in a specific zone or specific site, which leads to reduced property. So, one weight percentage shows the feasible in terms of tensile and flexural during the development process. So, here the one weight percentage uh, value is very higher in all the aspects. So we have observed that it will be feasible. So that's why we have developed the product on all the three weight percentage. But after evaluating this tensile test results and this flexural test results, it has been observed that the values are improved in this one weight percentage solution. Then this one is the few images, in-house images of our laboratory system, which we have used for this development procedure. So for that purpose, this gentleman, Mr. Joginder Kumar, is performing the development of this nano composites pipe in our laboratory. So few phases are mentioned in this PPT. Initially, we have total 7 number of images. So second number is the sonication process. Third number is the stirrer process. Fourth one is the mixing of this hardener and this epoxy. Then this development phase is there. spray is spreaded over this uh, this bottom surface to uh, avoid the sticking process. Then, with the help of a pipe, we have roll out this fiber sheets and the mixture of this epoxy hardener and reinforcement. And after this and hand layer process which we have used, and we finally we have rolled up these sheets and this solution on a pipe. So layup of this pipe is finally performed here. So after the solidification process, pipe is the internal pipe is removed, and we have this hollow pipe. So this pipe could be used for as a purpose of electric pole, as a pipeline procedure in water supply also. So different areas it could be used, as the tensile test and the result of flexural test shows the feasibility of this develop in-house nanocomposite material. So this one is the development procedure in materials and morphology lab of our university. So we have developed this product, and with the as per the industry need, we have prepare the dimension of these pipes. So after that, this one is all about my study, and after that we have conclude overall we have performed. The job is very lengthy. Here we have developed the material. Then after this fabrication and phase, we have characterized the material. Characterization in this characterization, we have performed the advanced characterization and mechanical characterization. After this fabrication and characterization, we have manufacture. Manufacturing process is used here in terms of drilling process, or several types of other machining process could be also used. And after this machining process, we have what we have control the process parameter to achieve the desired value of machining response. So here we have used this combined compromise solution. So one by one summary of all the chapter is mentioned here. So initially the this study is a total three phases. We have divided the study into three phases. So work is initiated from development phase to the end product development through academic, laboratory, and industry support. So in a brief way, I have mentioned all the aspect of the present job. So the X-ray diffraction and the SAM analysis shows that the opted fabrication method have a good dispersal. That is, here the uniform dispersion of this nanomaterial, that is GO, into this epoxy is a very significant and satisfactory way. Also, the results of DMA shows that the 10 delta plot decreases with the add-up of GO content and CF into the epoxy phase. So this tan delta shows the increase due to enhanced interfacial adhesion between this reinforcement material. After that, the improved storage modulus of geo enhanced CFRP increase this load bearing strength of the modified material. So here the addition of geo is also improve the load bearing capacity of this proposed material. And in our study, we have also observed that the uh, neat carbon fiber, that is simply there is no any addition of this nanomaterial. Simply in CFRP, we have 625.79 tensile strength, MPa tensile strength. And after addition of this nanomaterial at 1 weight percentage only, it shows an improvement of 33.03%. So it is very easy to remark that the properties are improved up to 33 times, 33.0 percentage from a normal CFRP, that is macro size fiber reinforcement polymer composite. It is there is a huge difference of the properties from 934.35 in this one weight percentage of modified epoxy by this nanomaterial, and in this neat epoxy, it is about only 625.79 MPa. So here is a huge difference or a significant improvement due to the addition of only of one weight percentage. After the further addition of this one weight percent will reduce the properties. So further addition tends to generation of some defect which could reduce the tensile and flexural properties. So one weight percentage is observed as a optimized not only from machining point of view, also from fabrication point of view. It shows that one weight percentage is feasible for this tensile and this flexural property. Further, in this neat CFRP having only 8.64 GPa of elastic modulus, and in this elastic modulus add one weight percentage supplement of this nanomaterial, it will raise up to 10.727. So there is also a difference in elastic modulus. It is it raises from 8.6 to 10.7. So it is also a huge difference of this elastic modulus of this neat CFRP material and this modified. Modified means what? Our nano material, carbon based CBN in the form of GO, it is about 10.727 GPa. So this is about elastic modulus, and further this is all about our tensile modulus. And from the flexural test point of view, further in a neat CFRP, it is only up to 289.95 of MPa of flexural strength. But in this addition of this one weight percentage of GO, improve the flexural strength about 442.55. So it is a very huge difference from 442, and in a neat it is only 289. So here again we have observed that there is a very high, very significant improvement in flexural properties is also observed here with the addition of this nanomaterial. So these enhancement, these improvement are highly desired. So as we know that there are some limitations in this macro size reinforcement. We have different types of reinforcement. We have glass fiber, carbon fiber, aramid fiber, Kevlar fiber. So different types of fiber is there. These are macro size. And further, if we are doping or if we are adding, supplementing this nanomaterial into this matrix in our study, it is epoxy matrix, and the macro size of this carbon fiber is used. So the results shows testing results shows a significant improvement in this tensile and flexural properties. So these tensile and flexural properties was further analyzed with the help of the damage analysis. We have performed the damage analysis during the testing. The sample which is fracture, which is broken after this tensile test and flexural test. We have performed the SAM analysis to study the surface morphology of the fracture and or the our sample which we have performed as per ASTM standard. The breakage point is analyzed with the help of this SAM. So which shows the fiber pull out and matrix debonding issues. And yeah, from that earlier flexural point of view, it is about 34.48 percentage improvement in flexural strength and about 33% improvement in our tensile strength. So approximately 30 to 35 percentage of improvement is observed only simply addition of this one weight percentage of GO. So this shows the feasibility of nanomaterials in this CFRP. So the results could be different for different macro size reinforced polymers. So here we have reinforced this our this nanomaterials into this epoxy, and approximately in both the cases we have achieved about 30 more than 30 percentage in both the cases of improvement in this tensile and flexural analysis. And SAM fractography, that is scanning electron fractography analysis, was used to analyze the fracture zone of this developed nanocomposites, and this proved the relationship between the microstructure damage evaluation and fracture generated in between during the tensile test and this flexural test. So the nanofiller agglomeration, which I have already told earlier, that the higher addition of this nanomaterial lead to agglomeration tendency. So it is an type of mm, issue or limitation of the study. So higher addition of this nanomaterial leads to this agglomeration tendency, which initiates the different types of cracks in the nanomaterials, and also reduce the toughness of the our material what we have developed. So experiment results also reveal that so this is all about this flexural test and tensile test. But after assuming this the result which we have obtained from this response point of view, so in drilling, the force is also optimized here. So it also these two types of cutting force, that is in form of thrust and torque, mainly governed by feed rate. So most of the studies earlier also shows the similar trend for other types of material. So here it has been observed that feed rate is highly responsible during the machining of not only composite, it is also responsible for the machining of the metals and their alloys. So feed, it should be controlled. It should be very balanced during the machining process. So higher feed rate uh, is responsible for surface defect also. So the combination of higher feed rate and higher speed, but not above a certain level. So this will define for different types of material, it should be different. So the speed and feed rate, the combination of both play a very important role. So at higher speed and low feed rate, the damages, the surface damages in surface roughness issues are there, and surface roughness defect is also there, such as fiber pull out at higher feed rate and higher speed. Chances of fiber is prone to damage. So that's why lower feed rate and higher speed is mainly preferred in the polymer matrix composite machining. And further, the geo weight percentage, that is nanomaterial weight percentage, play important role during the quality of the machine surface. So geo improve the machining surface issues also, and it improve the bonding between the different types of microstructure, our grains. So the addition of this geo also improve the grain strength. Bonding strength is improved, which is highly desired in efficient machining environment. After that, we have the surface morphology issues is also defined here. So the surface is smoother surface is obtained at lower feed rate and higher spindle speed at one weight percentage of nanomaterial addition. So it is observed that the surface of the machine sample is improved, or improved machine surface is achieved at lower feed rate and higher spindle speed. Am I audible to all of you?
Yes, sir.
Okay. After that, we have also the increasing this feed rate is not only responsible for the surface issues or material removal rate, it is also responsible for delamination damages. As we know that if the feed value is higher, if the feed rate is higher, then what? different layer of this macro size reinforcement is delaminate. It will removed out from their stacking. So in laminate types of polymer, the feed rate play a very important role. So it is mainly due to chisel edge of the drill bit. So higher movement or the fast movement of this chisel edge of the drill bit into the laminate polymer leads to the chances of delamination. So it is a type of major damages, especially in drilling process. So the influence of the parameter play a very important role to removed out different types of damages, or it is not possible that we could or we can completely perform a ideal machining. But it is not possible. We have to only reduce, or it is only possible to reduce the chances of damages, chances of failure during the machining process. But 100% of ideal machining is not possible in not only in polymer, also in metals also. So the chances of damages during the machining process is reduced with the help of this process parameter control. So for the control of this process parameter, we have different types of optimization modules. So we have used here this very novel and innovative optimization modules, so which reduce the chances of damages. So further, at one weight percentage of this addition in this CFRP, this also reduces the chances of delamination. So spindle speed is also play a very important role. Feed and the combination of this spindle speed and feed play a very important role. So spindle speed positively affect the delamination. It soften the matrix material. So at higher speeds, at higher rate of cutting speeds generates the deformation zone, and at higher speed also the in mating surface means the tool and the job which is to be machined, the temperature between this machining interface enhance or increases due to this plastic deformation is there, and which remove the material, and this plastic deformation reduces the forces. And after this SAM analysis, we have performed the SAM analysis at different weight percentage also at 1, 2, and 3. At a higher amount of nanomaterials results in some pores and surface holes issues in the sample of 3 weight percentage, as well as there is also non-uniform surfaces. But when we are observing this 1 weight percentage of GO, so the surface having very less defect and other types of damages in only this 1 weight percentage. And also in this a typical type of defect is also observed in this 1, 2, and 3 weight percentage. In 3 weight percentage, it is higher. The chances of fiber breakage is higher. Observe fiber pull out is also there, and also matrix is also deformed in 3 weight percentage. And uh, after observing this thrust and this torque, that is the force values, so it also affected by this feed rate, and these are the results for different responses for surface. And ANOVA also defined or estimated the importance of the process parameter. So ANOVA also shows that feed rate is the most prominent factor. So ANOVA is first one prominent factor, then second one is spindle speed, and third one is weight percentage. But this dominancy of this feed rate play a very important role during the machining process, any types of machining process in the polymers. So we should properly take care of this feed rate and spindle speed. During our machining programming, we have to take care about this spindle speed and feed rate for a favorable machining environment. Probability plot, that is the residual plot which I have earlier mentioned. This in residual plot, we have what? Straight line with dotted red points. So these red points surrounded on the this straight line. This shows the little deviation from the standard values. So this also indirectly shows that the experiment which we have performed, is a very efficient in a efficient way, and the chances of error is less. Similarly, uh, so this one is about this force, and this one is about ANOVA analysis. But earlier, one important aspect of this present job is the PCA analysis. So in PCA, we have also estimated the contribution percentage of the responses. So these contribution percentage shows that how much effect of these contribution or the different effect on the final objective function value. So this PCA define the contribution of all the responses, that which one is important to control. After that, we have also used this PCA and then this optimization module, that is combined compromise solution. And the result of confirmatory test also shows the improvement in the surface roughness. And surface roughness, we have RA and RZ value. So RA is improved by 13.79 percentage, and this RZ is improved by 24.81. Improve means what? This is not achieving the higher values, these are reducing. The nature of surface roughness is lower the better. So that's why in terms of reduction, it is about 13.79, and reduction in surface roughness, that is RZ value, it is about 24.81. And from circularity error, it should also the behavior of lower the better. So it is about 26.84 into the preferred solution value. So these values, that the lower the better behavior of all the responses are achieved in this study in a significant way. And this improvement, 13%, 24%, and 26.84% in a preferred solution value, this shows the feasibility of this optimization module. And this not only optimization module, also the addition of this PCA embedded COCOSO solution. Finally, the conflicting machining performance, we have changes all the responses value a single objective function. So the single objective optimization could also feasible through this traditional optimization module. So in this series, the Taguchi based optimization modules are widely used in industries and in academia and research sector. So this but the major limitation of this traditional Taguchi method is what? It is feasible for single function only. But when we have two or more function, then the major limitation of this traditional Taguchi is that it is responsible for, or it is feasible for single response only. So for that purpose, what we have to uh, convert all the multiple response into a single objective function value. Then the objective function value introduced in this traditional optimization module for the purpose of optimal set of process parameter. So we have changes all the multiple responses into a single response value. So after that, we have also performed the confirmatory test at the optimal setting. So in our study, the optimal setting is this 2400 RPM, feed rate is 80 mm per minute, and optimal from weight point of view is the one weight percentage. The value of both the indices of surface roughness, it is decreased from 1.80 to 1.55 micrometer, and RZ is 2.9 to 2.50. So this one is a very huge changes in the surface roughness. So reduces, it is reduces. Circularity error also reduces from 0.133 to 0.100. So this one is the main output of this study. So the total job which we have used here consist of this fabrication to this product development phase. So this study mainly deals with the development, and then characterization, and then machining, and then optimization, and finally the product development phase. So this one is all about the this material study from machining point of view, from nano material supplement into this macro reinforced CFRP composite. So this is all about my presentation. And if there is any query, so one by one, please inform me. So this is over from my side.
Thank you so much, sir. Dear participant, if any query, any question related to sir presentation, please ask. Hello.
Hello.
I think no question from the audience, sir.
I think no question from the audience, sir.
Okay. So any other faculty member or who is also the participant of this FDP? So they also please. I have also mentioned my PPT at the starting in my presentation. I am also showing my email and mobile number is mentioned here. So if there is any further questions related to this presentation or this nanomaterial supplement into this CFRP and from this initial development phase to product development. So if there is any questions, so please contact on my this number
Good
and
morning, sir.
email ID. Yes.
Good morning, sir.
Mm-hmm.
Sir, I am research scholar from institute. Having some doubts, sir, regarding
Yes.
regarding copper.
Yes.
Right now, I am going to do my research under copper composites. Sir,
Mm.
is it possible to manufacture using powder metallurgy
Mm.
by incorporating copper powder with some of the silicon or ceramic particles, sir? Is it possible?
What is your matrix material?
Sir, powder,
Actually,
that is
copper or
powder.
silicon, whatever you are using as a reinforcement, what is your matrix material?
Main composite is copper, sir,
Okay.
and copper with the silver and ceramic. Some of the ceramics, sir. Is it able to possible
Okay.
do this combination, sir?
Okay. So you are preparing ceramic matrix composite, right?
Yes, sir. Yes, sir.
Okay. So your matrix is ceramic, eh? And
It's
your
not
reinforcement and you are using copper as a reinforcement with silver, right?
no, sir. Main proportion is copper, sir. I'm reinforcing ceramic as a so it is metal matrix composite, sir.
You are using ceramic, na?
Yes, sir. I'm using ceramics, sir. Silicon carbide like that, sir.
Okay. Okay. So yes, it is possible that in polymers also people are using some these low temperature elements such as copper, aluminum, silvers. So few of the novel studies recently a trend is observed in the studies that the addition of this copper types of powder with the help of this particulate form the mixing is possible with the help of this powder metallurgy. It is possible.
Okay. And anyway, any techniques apart from the powder metallurgy to incorporate this one, sir?
Yes, actually you have to prepare the mixture in the form of powder. In powder metallurgy, there are different methodology to change any types of particles into the powder form. And after achieving the powder form, you convert or you mix this powder into your ceramic or SiC.
Okay, okay. Sir, can you any idea about cryogenic treatment, sir?
Cryogenic
And
treatment is after the development phase, na?
yes, sir, yes, sir, yes, sir. After development, after
You
producing the
prepare.
powder,
Yes, yes.
after
Actually, firstly, you have to define the potential application of your product, whatever you are developing in form of composite, in form of product, and after defining the product, then you have to define the application at higher temperature. It is need for higher temperature or it is need for lower temperature. If for lower temperature, then it is feasible that you can proceed for this cryogenic treatment also.
sir,
But
actually,
initially before starting any types of treatment, you please perform some mechanical testing. that how much material is available to withstand at different temperature, different pressure. For that purpose, you have to perform some mechanical testing such as tensile, flexural, or some temperature-based testing is also there. TGA is also there,
Okay, okay. So
or
thank you, sir.
other
Thank you.
temperature related further some testing is also there. So you please go through some testing related to temperature. If you are really want to use your material for some minus level of temperature or plus level of temperature, whatever your need. So please try to read some different types of testing of the material. Then proceed finally development of product. You proceed for your treatment, any types of treatment. But initially you have to investigate the temperature or investigate the behavior of your material. Whatever you develop, is it really feasible for higher temperature or not? Firstly, initially you have to perform some testing of the materials.
Sir, thank you very much, sir, for kind reply, sir. Sir, in case if you are having any doubt, I will, if you are free, I will call you, sir. Thank you, sir.
Yes, sure. At any time, my number is also there. Email is also there. And
Thank you,
from your Dr. Sabindra sir, you can collect further more information about my job on my university portal, that is mmmut.ac.in.
sure, sir. Thank you. Thank you very much, sir.
Thank
Some
you, gentlemen.
question, write some in chat box, sir. Professor A. Wes, what are
Yes,
the different industrial 4.0 technology that can be used in manufacturing?
Industry 4.0 is a very latest uh, in Industry 4.0 there are different types of manufacturing or different types of methodology is there. So as we know that nanomaterials is a very innovative and latest field of investigation, and there is chances of improvement of material properties or product properties with the help of different types of addition of or the supplement of different types of nanomaterial. So for Industry 4.0 point of view, the nanomaterial or the polymer material are very important. Hello.
So I think there is no other query.
Okay.
So, sir, I have one query related
Yes.
to composite.
Yes.
Sir,
Yes.
what are the basic things when we develop some we choose as a natural composite? So, what are the basic things the on the material? Then we can go for the ahead for the development of composite.
Okay. So you have asked a very important and very innovative question, that what are the important things for selecting any types of natural composite, right?
Yes, sir.
So natural composites, these are green composites, right?
Yes, sir.
So these are readily available through nature, such as have you listened about this basalt fiber?
Yes, sir.
Basalt fiber is also and a composite reinforcement. And in this natural composite series, there are different types of natural fibers we have. So availability of this reinforcement of or any types of raw material. First one is the availability. Availability will define the cost effectiveness. If let us suppose if we are selecting this a very high rate of carbon any types of material, either it is aramid fiber, kevlar fiber, or carbon fiber or basalt fiber. So the availability of raw material, first thing is the availability. Second one is the cost issues. We know that if our initially our reinforcement is very higher, then it is not possible to produce a cost effective product. So availability and cost effectiveness of the different types of phases, either matrix phase, reinforcement phase, or nano reinforcement, it should be lower. So first one is the availability, second one is the cost effective issues. Then we have to also target the properties point of view also. But if we are developing any types of product and it is not cost effective, then it is not good for society interest. So first one is availability and then cost effectiveness.
Sir, if the if you talk about the fiber, so before going to develop we can first check the fiber strength, or we directly go for the development?
No, no, no. Firstly, you have to investigate the fiber properties. In my case, I have also mentioned some fiber properties here.
Okay.
So before starting any types of investigative or experimental study, you have to investigate all the aspect, all the properties of fiber, properties of reinforcement, properties of hardener, properties of nanomaterial, properties of metric space, and properties not only from their strength point of view, also for temperature point of view, also for pressure point of view. So different actually the composite is undergone for temperature features also, pressure features also, so it should sustain. We know that the matrix and the combination of this fiber, the combination of both the items will produce a solid type of product. So we have to initially checked out or investigate the properties. It is very essential.
Okay, sir. Okay. Okay. Thank you so much, sir. So I think there is no question from the participant. So we wind up, sir.
Yes, yes, yes. My email
Yeah.
and contact
So
number is also mentioned.
yeah,
So if anything
yeah, yeah.
have any issues related to this development, actually we have some facilities of development also, and but some machining facilities we have outsourced, and testing is also outsourced. So for the development purpose, I am available at any time.
Okay, sir. So thank you so much, sir. I request to Abhishek MS, please conclude the session.
Okay, sir. On the behalf of all the coordinator, myself, and a participant for making time out of your busy schedule and provide a valuable information, like in all the technical issue and like network issue you have delivered a valuable lecture for us. Like I would like to extend a sincere thanks from our side and like all the participants, sir. Thank you, sir.
Thank you. Thank you very much. All the best.
Thank you,
Yes,
sir.
sir.
So, dear participant, our next speaker is Mr. Irwin Osman Topo, sir. He is currently working in JB Pant Engineering College, DTU, Delhi. Sorry. So he joined soon. So we are not today. We not take any break. So I call him and join right now. So wait for some minute. So our next speaker will join soon. So not go for anywhere.
ज्वाइन कर लिया ना?
हेलो हेलो Abhishek, hello, I'm
Yes, sir,
audible,
you are
Abhishek?
audible, sir.
Yeah.
Yes, sir.
So our next speaker, Mr. Irwin Osman Topo sir, will join us. So I am very again good afternoon to all of you, and I I am most welcome to Mr. Irwin Osman Topo sir, and I requested to Mr. Abhishek. So please introduce brief introduction about the Mr. Irwin Osman Topo sir. Please, Abhishek.
Very good afternoon, everyone. Good afternoon, sir. Irvin Osmondo Toposa, he did his Master of Engineering in Mechanical Engineering from the one of the reputed institute of national importance known as Indian Institute of Science, Bangalore. He has industrial experience from Bharat Heavy Electrical Engineering BHEL as design engineering in the field of designing of mechanical auxiliary system for power plant. He also served as a faculty in the Department of Energy Engineering in Central University of Jharkhand, Ranchi, currently working as assistant professor in DSEU Okla Campus 1, formerly known as GB Pant Government Engineering College, in the Department of Mechanical and Automation Engineering, selected through UPSC. He is also pursuing PhD from the Department of Applied Mechanics from Indian Institute of Delhi. His research interest lies in the area of computational fluid dynamics and heat transfer, numerical simulation, developing indigenous code for solving fluid flow problems using open source code, OpenFOAM. We are happy to have you, sir. Over to you, sir. Thank you, sir.
Thank you, Abhishek, for the brief introduction. And thank you, Dr. Savinder Kachap, for inviting me for this talk. And on behalf of Savinder, Dr. Savinder, I would like to welcome all the participants who are there to listen this talk and participate with me to understand the significance and importance of CFD in the field of green technology and renewable energy. So, are you able to hear me,
Yes,
Yes, sir.
yes.
Abhishek? Yeah, fine. So I shall start directly to the. I'll start directly to the slides now. So just help me out if you're able to see my slides or not. I'll share my screen. 1 minute. So are you able to see my screen, Abhishek?
No, sir. Not now.
Yes, 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 sir.
Yes, sir.
Is
Now
it
it's
visible?
visible, sir.
Okay, fine. So 1 minute. Just give me a second. Having some difficulty in moving through the slides, I guess. 1 minute. Just give me a second. There's some issue with the. So I think there is 1 minute.
Slides are changing, sir.
Slides are changing, but actually the full view is not coming. I'm trying to. So are you able to see the full screen? I mean, without.
No, sir. Just slides,
That's
sir, before the full screen. Yes.
just a minute. Just a minute. I'll just. Now, are you able to see my screen?
Yes, sir.
Yeah,
Yes,
fine.
sir, yes, sir.
So now we'll start with the presentation. And so basically what we are going to deal with today is we are going to see the application of computational fluid dynamics in the area of green technology and sustainable engineering. So now basically before starting with the CFD, I think most of the people are already aware what is CFD and what basically. Yes, pardon. Yeah, so basically this is the outline of the presentation, which is like what is CFD. We'll go through just a brief introduction of what is CFD and why CFD is required. Then the cost of the CFD in comparison to the experiment, and then we'll see briefly the uses of CFD, and then we'll take few examples like where it is used and how it is used, and what is the basically the purpose and what is the insight the CFD can give compared to the experiments. And then will be most important part of it is most important part of the presentation is the case study actually. So what this case study means, we are going to see the different cases which have been performed by me, and there are a lot of data which we have generated, and we'll try to see what is the role of the CFD and what is the difference between the CFD and the experiments, and what are the different things which CFD can provide compared to the experimental things. So these all experiments and the all simulations are done based on the open source code, open form. So we'll also see how this open source code works actually. Okay. Now, what is CFD actually? So CFD basically if you might have been aware of all these things, is a science of predicting the fluid flow, basically the fluid flow, the heat transfer, and all the related phenomena. So basically what we are doing in CFD is we are trying to replicate the actual situations which involves fluid flow, heat transfers, and there are several applications are there by solving the governing mathematical equations. So what does this mathematical equation means? Like mathematical equation means like all these real situations are actually modeled in the form of mathematical equations, and those mathematical equations, when you solve it, you basically predict the situation, how it's going to happen, or what are the different external or internal parameters which are going to affect the motions or the phenomena. So basically CFD means like you are solving basically a set of mathematical equations by using different tools. Now what does CFD involves? So you already know the mathematical modeling of a physical phenomena, which involves fluid flow, using different numerical methods and using the high computer power to solve those mathematical equations. So basically CFD, if you have gone through the course, you will find that CFD involves a set of mathematical equations, and those set of mathematical equations are sometimes are non-linear in nature, sometimes it is difficult to solve directly. So what do you want is to solve those equations, you need numerical methods, and different numerical methods are there to solve those equations and analyze the data. So basically CFD is again, it one of the part of the CFD is to solve those equations using different schemes. Now the application part, if you see it involves it is used in the field of industry. It is used in the many fields of industry, in aerodynamics, in aerospace analysis, in weather simulations, natural sciences, environmental engineering. So it has got a very wide applications. So I mean, right now I think most of the industry, before going to any production, what they do is they try to simulate those things and try to find out where is the gap in the designing, or is there any problems before making that product available to the customers. So basically it's a very important tool to analyze those things. So if you see this one of the figure, it's just and the cartoon actually where this Formula One racing car, and if you see the streamlines are there actually. So lines are basically telling how this flow of the air passes through the vehicle actually, and it is used to streamline the vehicle so that you can reduce the drag. Why CFD actually? See, there are a lot of applications where it is very difficult to actually replicate the actual situations. So sometimes it is like, and it is also a very costlier thing actually, because you cannot afford, you cannot always afford to distract the uh, you cannot afford to do the destructive analysis all the time actually. It's sometimes very costly. So, and sometimes, for example, if you if some for example, if you are launching a missile, okay, and you're trying to find out the what is the trajectory and how it's going to follow the path. So before doing the experiment, what you do is you try to simulate those things and then see exactly whether it is following the path or not. So that can be very expensive task if you try to do it experimentally, because sometimes, and also there are things which you may find during the experiment that it should have been done before the experiment. So this CFD provides you an opportunity, it gives you a luxury to understand the experimental things before doing the actual experiment, and then so that you can improvise those things, uh, you can reduce the problems, you can actually smoothen your experiments. And it also saves time actually, saves times in the sense, compared to the compared to the compared to the conventional testing and data, sometimes you need a real time data actually, and that may not be possible in case of the experiments. So what CFD gives you, it gives you a real time data also. So it helps you to understand the physical phenomena well in time, and also it gives you the actual uh, actual analysis, which may not be possible in case of experiments. You may not be having the proper uh, proper equipments, proper data analyzer to actually analyze those data. Okay. But one of the most important constraint in CFD is it cannot be replaced by the experiment. Okay, so that is the one of the most important constraint actually, because physical experiment. See, basically what CFD is doing is it is solving the set of mathematical modeled mathematical equations, and those equations may sometimes it happens that the equation which is used to model those equations may not be correct. There may be some limitations involving those mathematical equations, and there are a lot of errors also. So we'll talk about all these things in a later stage. But this is again, it can be sometimes it can be very expensive depending upon the size of the domain, the size of the computational power required. So all these things makes it sometimes costlier also. So basically, what I told you is does not remove the need for the physical testing, but of course the CFD changes the nature of the testing and experimentation. So it can actually give you an accurate simulate. It can accurately simulate any model, and and can help you to improve the designs also. So basically, the importance of CFD, it is cheaper, because if you take the example of doing an experiment which involves the wind tunnel. So if you have ever visited any of the wind tunnel labs and all, it's very huge, and it takes lot of power and lot of manpower and everything to done a single experiment. So it is sometimes very costly, but if you use CFD, you can actually reduce a lot of cost, and can get the data which is very comparable to the experimental values. So it gives you the flexibility in terms of designing and modifying the models, and also I mean it gives you the deeper insight compared to the experiment. So this is one of the picture where it is you are actually trying to do the experiment So what you are doing is trying to make a prototype of an airplane and trying to do the experiment. So this is one of the experiment. In the other figure which I'm trying to tell you is one of the experiment which we did. So this is bubble rising bubble coalescence experiment, in which you are having a column of water in which you are trying to put a bubble and see how this bubble behave in this water actually. So this is one of the most widely used applications in the field of uh, widely used field in industry also. So we'll look at all these things when we talk about the experimental, when you talk about the cases actually, which will come later in the slides actually. Now, so if you talk about the process and methodology of CFD, so basically what it involves, it involves. So first of all, what we have to do in CFD is basically first we have to define the geometry of it. So what is the physical bound of the problems. Now this, what is this physical bound means? Suppose if we want to simulate a car or a particular part of a car, so it's basically depend upon on which area you want to concentrate. Okay, sometimes you want to uh, uh, simulate the whole car, or sometimes you are only interested in the front part of the car, or sometimes you only more interested in the tire. So basically it's depend upon on which part of you are considering for the analysis. So based on that only your geometry is decided. Okay, then the volume occupied with the fluid is divided into discrete cells. The mesh may be, now what we do is, now when you decide your domain, once your domain is decided, you take that domain and you try to divide it into the small cells actually, small volumes. And these volumes are basically these are the volumes which on which all the governing equations are solved actually. Okay, so this is what means the cells actually. Okay, and then mesh, depending upon the mesh may be uniform, it may be non-uniform, it may be moving. See, all these things are there. We'll talk about all these things in a later stage. Now once your domain is decided, you discretize your domain, you have a mesh. So what you need again is now try to understand the problem. So unless and until you understand the physics of the problem, you cannot implement CFD. Suppose, for example, if you try to simulate a cup of tea which is placed inside a room. So unless and until you understand what is the phenomena, what is the physics behind all these things, you cannot implement CFD. Okay, so suppose if I put a cup of tea inside a room, what will happen? There is a convection which is going on, and there is a conduction which the with the wall of the with the tea and the surfaces, and then you have different other forces, other heat transfer activities which is taking place. So depending upon what are the things which you want to take care, and what are the things which you need to involve. Uh, Suppose the air is static, so I can neglect the convection if it is allowed. So depending upon all these things, you need to understand what are the physics, what is the physics involved in all these processes, and then you have to take into consideration all these things while simulating. Suppose you wanted to introduce some other forces. Suppose it is, if you have a magnetic field also in and around your room, and you want that magnetic field also to see the effect of that magnetic field in that cup of tea, how the energy loses or how the heat is evolved or dissipated in the presence of the magnetic field. Then you need to model that magnetic fields in terms of some kind of mathematical equations which may be available with that code or may not be available with that code. If it is not available with that code, then you have to write your own code to implement those things into the equations and then solve based on that. You can solve those equations and then you see how the dissipation of energy takes place in the presence of the magnetic fields, which also involves other parameters. So this is one of the most important. So analyzing and understanding the physics of the problem is very important before implementing the CFD. Then the another part which is very important is the boundary condition. What boundary conditions you need to, what you need actually. So boundary conditions mean, see, when you have a domain and your domain have all the boundaries, suppose if you have a pipe in which the water is flowing, so you have a inlet conditions, you have outlet conditions, you have the pipe which is surrounding the fluid. So all these things is, now what if you want to, suppose for this example, if you want to simulate this flow inside the pipe, actually the water is flowing, so you have to give the input at the entrance. So it can be a velocity input, it can be a flow, mass flow, it can be a velocity, volume flow rate, anything. And then suppose, and similarly at the other end, you can have outflow, you can have a zero gradient, you can have. So all these boundary conditions also very important. So CFD understands your requirement. What are the physical constraints? What are the physical boundary conditions which are present? And based on that, you simulate those things. So once you give all these things, then you select different scheme for the discretization, different scheme for solving the momentum equations, different schemes for solving the heat transfer equations, and then you decide whether it's a transient or the steady state, and then based on that you move forward actually. Then once it is simulated, once this all the mathematical calculations and everything is being solved, what you are left out with the results actually. Then again you need a post processor, you need to analyze and visualize the results, and you see. So before assuming that you have achieved the results, you have to analyze those results and compare it with the experimentals or existing literature, or your basic understanding of your physics also. So, also helps you to understand the results which you are getting. So uh, once your code is validated, uh, your set of equations are solved correctly with the correct boundary condition and everything, the results should also match with the physical phenomena. Okay, it should not be different from the physical aspects of the problem. The physics should follow all the time. Okay. Now these are the different capabilities of CFD. Capabilities means what it can do actually. What are the different things which can do? So it can help you in the motion analysis. Motion analysis, any kind of motions, it can help you to analyze and find the results. Then you have a, if it is you, and then again you have a calculation of shielding effect of ships and barriers. So this is one of the experiment in which you have a fluid and structure interaction actually. So if you in the field of ocean and engineering, you have a different uh, series simulations where they try to find out the impact of the waves on the surface of a structure. Okay, so these are all done. Then hydrodynamic interaction between the bodies actually. So we'll see one of the example later on. So it's like you have a surface, you have a interaction, hydrodynamic interaction between the different bodies and the body and the fluid. So all these things are there, and then there are again there are apart from that there are powerful modeling and result. So now once you are familiar with all these things, what you do is try to introduce new ideas to the CFD. So like open form or any open source code, which it gives you a freedom to implement your ideas. Once you are used to the code, what you can do is you just think of the problems or think of the physical aspects of the problem, and then you can, based on that, you can implement your ideas into the code. Okay, and then you can see beautifully how this CFD works and gives you the different uh, uh, unexplored areas. It gives you a glimpse of the unexplored areas, different ideas to help you understand the nature of the problem, to understand the physical problems. Then you have a multi-body interactions. The multi-body interactions, you have a different bodies which interacts. Maybe heat transfer. It may be a case of fluid surface interaction. So those things can also be simulated. Then it is used in the field of wave and wind energy systems. If you use, you must have seen a lot of simulations done on wind energy, wind turbines. All these things are there. Then you can also perform the stress analysis on different parts of the machines. Then you have transportation of large offshore structure using ships and all. So I have, as I have talked earlier. Then you have float over analysis, the lifting operations, vessels. Then again, another very important thing is the scaling of the existing model, how you scale actually. So sometimes what happens, you suppose you are trying to do the simulation for the vehicle, for any particular vehicle or a car. So now what you want is you want to you have produced the prototype of it. Okay, so now the scaling, using the scaling analysis also, you can actually see the impact of all the forces which is acting on the prototype and trying to scale it for a larger volume or for a larger size. So basically it also helps you to find the forces uh, in actual model actually. So when you do it for a prototype, you can actually scale it and see how it will happen, or how these forces are going to affect when you're making a full size model. It has got limitations. The limitations mean, as I told you, these are all set of mathematical equations. Okay, numerical, and these mathematical equations are basically solved using numerical methods. And if you remember, this numerical all these numerical methods involves errors actually. These are truncations errors, there are round off errors, so all these things are errors are there. But of course you can actually if you are good with your equations and all, actually you can avoid all these errors, and actually you can get the results closer to the experimental values also. Now, once this geometry become very complex, if it is very complex, what will happen? Your size will increase, your complexity will increase, and those geometry involves the finer meshes actually. So finer is the meshes, more is your computational power, and also other factors are also involved depending upon your flow parameters. So if your flow parameters are different, you have a very high, sometimes you encounter, in case of the fluid flow, if you have very high viscosity and you are taking into consideration of the turbulence characteristics of the flow, you are also considering the high Reynolds number, then your computational power also increases, because you need to resolve the finer meshes, you need to resolve the meshes which are distorted, which are moving. So all these things comes into play, and it ultimately increases the computational costs of the simulation. Okay, but again, as I am re-emphasizing, it cannot replace the experiments actually, because experiment is something which is the most important and the most real aspect of solving the engineering problems, because you see actually what is going on, because other CFD and everything is based on the mathematical equations, and it involves a lot of numerical methods. And if you are not taking the correct numerical methods, and if you are not able to analyze the physics of the problems, you may land up with results which are not in concurrence with the experimental values. So all these things are there before doing the CFD. You need to understand all these things. So just to give you one of the example, one of the experiment in which you have a block which is placed on the fluid surface, and is placed, and here this in this again this is an open form simulation in which the dynamic meshing is used actually. So dynamic meshing is like the mesh deforms based on the requirement. Okay, so this is the mesh is not of the same, it's not of the same size actually. It deforms based on the requirement. So now these kind of experiments actually gives you the insight of the fluid surface interaction, how the fluid interacts with the surface, and how what are the forces which is being experienced by the surface when the fluid try to act on it. Of course, it's also depend upon the fluid properties, your surface properties, and other lot of other external flow parameters. So it helps you in understanding the force acting on the block due to the fluid. So this is one of the widely used application of it understanding of the stability of the structure, because if you try to build the offshore structures in the seas, you'll have sometimes the waves become so violent it can destroy the pillars and all. So before designing and before making all these things, the CFD simulations are done, and it helps you to understand the stability of the structure. So this is one of the simulations in which this open source open form is used, and then you have a block which is placed on the surface. In fact, not on the surface, on the below. I mean, it's so trying. What is the idea is like to understand the stability of the block. The block is placed, and then it is given some kind of force to move from his place, and then see how the stability acts on it, and how the waves are formed. So if you see on the left hand side, you have a mesh which is deforming with the time actually. Okay, and if you can really see how this splashing of the fluid is taking place, and how this rolling of the object is taking place. So this is helps this one of the this it helps in understanding the propagation of waves also. So how this, suppose if you have a ship in an ocean, and the ship moves, how the waves are going to be produced at the surfaces. So the nature of the waves and the kind of the energy which it generates, it helps in understanding those things. Okay, so basically the application part of it is used in the ocean engineering to understand these waves and all. And if you see on the left hand side, it is giving the velocity actually, what are the velocities. So you can actually see where the maximum velocities are produced, and how the velocity is getting dissipated, or how the velocity is, it's in the over all the domains. You can see this. Okay, on the right hand side, you can actually see the water and the structure, how it is interacting with each other. So this is one of the example where you see this fluid surface interaction, and it helps you to understand the different kind of forces, the different kind of motions which it generates. Now another example of this is again, you have this structure. This is the forces acting on the structure because of the fluid motions. So if you see again, this is the wind is flowing from the left hand side, and it hitting the structure, and structure bends. Okay, so basically again, this is one of the example where you have a wind which is flowing and hitting the structure, and you see that how this structure is behaving in the presence of this fluid. So again, this also very important to understand these kind of phenomena. Why? Because if you see examples, you have a bridge where you have a strong wind which is flowing across the pillars, the structures, and how these pillars and structure behaves actually. Okay, so all these design engineers try to understand, so what is the frequency of the vibrations, what are the different frequency at which this structure will vibrate when they encounter those kind of flows. The flows with different velocities, different, and also very important, like how what is the flow parameters and what is the nature of the fluid which is hitting the surfaces. So again, this helps in understanding the nature, understanding the structure design. It helps in understanding the designing of the structure. It helps in understanding the structure of the. It helps in understanding the stability of the structure. Okay, so these are the small experiments which can be done to understand the fluid surface interaction. Now, in terms of, if you see in terms of the renewable energy, it is widely used in the field of uh, CFD analysis, in the field of solar energy, where you do the CFD analysis of the solar panel and try to understand the different uh, different heat transfer processes uh, which is involved in the solar panel construction, designing. Sometimes the panels are designed based on the CFD stability results, strength results, and different things actually. Again, the another major importance of important application of CFD is in the analysis of the biogas plants, or the plants where you have a energy which is being used in the form which is used in the renewable energy sectors. So we are going to see those examples, and we'll try to understand the use of the CFD in those areas. The another example of CFD analysis is in the field of fuel cells, because there are a lot of things, but lot of research which is going on in the field of fuel cells, and CFD plays a very important role to understand the insight and try to, and it helps in understanding the designing of the fuel cells. Another widely used application of the CFD is in the wind turbines actually. So if you see any of the wind turbines, all these wind turbines undergo a very undergo a very tough CFD process. They analyze each and every part of the wind turbine, and then try to modify the design based on the results, and then finally the production starts, and you see the lot of you see the wind turbines coming into existence. Okay, so this basically involves lot of research and a lot of CFD analysis, which is being done to understand the wind turbines. So this is one of the applications where this uh, solar heater is being used. CFD on the solar heater is being done, and try to find out the heat dissipations and how the velocity profiles and the temperature profiles looks like. And this is again a solar panel, and in which your velocities, and you're trying to see how the velocities are being distributed over the panel. So these are the few examples where the CFD comes into play in terms of the constructions, in terms of the designing of the solar panel. Now this is application wise. If you see, there are a lot of applications which involves the biogas mixing plants, where this CFD is used, and try to understand how the mixing process between the two phases takes place. So sometimes it can be two phase, sometimes it can be multi phases, multi-phase multi-phase properties which are involved, and how these phases interact with each other. How, and also important to understand the chemical process which are involved in these kind of biogas and mixing plants. So CFD, before again, as I told you, before going to the experiments, the CFD simulations are done to understand how this reactors biogas mixing plant works actually. And And this is one of the picture which is showing the mixing of the two fluids actually. Now this is the another picture. If I tell you, these are the streamlines, the velocity profiles. If you see inside a mixing chamber, so basically it gives me the insight of how the velocity profiles look inside the it's a mixing chamber, and how these are different parameters will help you to enhance the mixing of the two fluids or mixing of the two phases. So this is an two-phase in an anaerobic digester where you have a which is used in the field of biogas plants, and this is how this mixing takes place inside. So another important application, as I told you, is the wind turbine. So this is again wind turbine experiment, which is wind turbine simulation, which is then done on the open form, and these streamlines, these are the velocity streamlines, and you're trying to see the velocity in the axial direction and how these velocities are varying when they pass through the blades. So once they pass through the blades, how they are, appearing, it is visible from here. So again, it helps you to understand actually the different phenomena, different interaction of the air or the wind with the turbine blades, and helps to understand the performance of the turbines, and helps you to improvise and to understand how the performance of turbine can be enhanced when you look at the different parameters and the results which is obtained from the computational fluid dynamics applications. Now this is so this is again experiment or the simulation which is done on the turbine blades. So basically this is the turbulent the process is turbulent, transient, compressible flow through the turbine blades. How when the compressible fluid flow pass through the turbine blades, how it looks like actually. So if you see this, it gives you the insight at on the bottommost on the right bottommost figure. If you see, so it gives you the velocity at the blades, so you can actually find out which portion of the blade is getting is being stressed out actually. It is facing the most stress. It's bearing the stress. So if you see the red color, it is basically telling us the highest the velocity of the velocity of the air which is there in the turbine blades. So basically this again gives the insight of where this velocity is distributed in the turbine blades. Okay. Now CFD simulations are not only for this kind of application, it also involves a rigorous are able to analysis are able to it also helps in understanding the topographical details such as terrain variations and structures in area, as well as local aerodynamics and turbulence. So basically again one of the important applications nowadays is the trying to understand the pollution. So so now there are different experiments which is done. Sorry for my bad throat. So CFD simulation of complex distribution of pollutants concentration within microenvironments of human exposures are feasible using today's high performance computing. So again, nowadays the pollution is one of the most important. The pollution is one of the problems which we are facing nowadays. And this also, the CFD also helps in understanding the the pollutions. I mean how the pollutions are distributed. So there are several experiments which has been done in Delhi, and try to understand how the pollutants are actually dispersed in the environment, and trying to understand what are the factors. Like if you see the weather forecast and all, they say that today wind is very strong, so you likely to have a very good weather and all these things, and in which direction the pollutants are coming, and because of the low pressure region or the high pressure regions, how the pollutants are going to be settled down in a particular area and going to affect the place actually. So all these weather predictions, all this distribution of pollutants in the environment, and all these things are done based on the creative simulations, and it really helps to understand the nature of the pollutants, and also gives you it also gives you the idea to how to eradicate or how to remove these kind of pollutions from the environment. So quickly now, before going through this, as I told you, one of the important we'll go through the different cases now, and try to understand the application part of the fluid computational fluid dynamics. So as I told you earlier, one of the important applications of the computational fluid dynamics is the use of the bubble column. So basically, what does bubble column means? Bubble columns are reactors are widely used in the process and biotechnology industries, and it's very simple in the sense it only has kind of kind of a chamber where you have a liquid and you have a gas which is flowing from beneath, and these gases interact with the liquid and then react, and then certain kind of products are formed. Okay, so now the application part of it, if you see this in terms of the green technology, is used in the production of the green fuel through hydrocracking of vegetable oil with certain catalyst, and it's also used in the manufacturing of the synthetic fuels which are environmentally friendly, is used in the treatment of the wastewater. So nowadays, if you see, if you have any visited any of the wastewater treatment plant, you will have this kind of apparatus which is there. So all these things are very simple in nature, but it helps in producing the green fuels. It helps in producing the synthetic fuels which are environmentally friendly. It is used in the treatment of the wastewater. So in this case study, we are going to see this how these simulations are done and how the important parameters which comes into play. So basically, if you see the application part of it is one of the hydrotreating of the vegetable oil in the slurry bubble column reactor for green diesel production. So how this, if you see from the beneath, you have the gas phase, which is the hydrogen inlet, and the liquid phase, you have a triglycerin inlet. So you have a two liquid, you have a gas and the liquid, and you have a sponger and the gas distributor where the gas distribute into this. Then you have a slurry, which is the liquid plus catalyst. Then the bubbles are which is being generated from the below, and these bubbles interact with the slurry and liquid, and then the reactions takes place, and as a result of the reaction, you have a green diesel which is produced, and then you have a excess hydrogen carbon monoxide, carbon dioxide at the outlets. So how this is, it's very simple in nature, but quite effective in the industry. So before starting this, simulations. This is again, uh, it's like you have a two fluid simulation of a dispersed gas liquid flows, and you have a rectangular in this simulations. You have a rectangular column which is of the width of 20 centimeter and depth of 5 centimeter and height of 120 centimeters. So basically, in the simulations which I have done is you have a air and water as a working fluid under the ambient conditions. You have isothermal nature, and the springer through the air is introduced in the column consisting of different holes actually. So now before going through this, I'll go through the details of it, but before that, I'll just tell you the flow parameters which involve in this experiment. So what happens is like through the springer, which is in the through the sparger which you have here in the bottom, the gas flows in the upward direction. So in this case, you have a air which is flowing. Okay, with there are two cases, two superficial velocities, 0.16 centimeter and 0.73 centimeter, and you have a inlet velocity. So in this experiment, this RANS model is used. Round average Navier-Stokes equations are solved using the two equation model of K epsilon, and these are the values of the K and the epsilon which is required for the simulations. Now, if you see this drag force model, lift force, virtual force, wall lubrication, the turbulent dispersion. So need to, as I told you, when these bubbles flow into the liquid, there are certain interaction of the bubbles with the slurry. Now, what are the forces which you want to take into the account, and the others which you don't want to take into the account? So suppose if I'm taking in this case the drag force model, I have used Sinclair model, and then lift forces I have used the model, and then I have left out the virtual mass and the wall lubrication and the turbulent displacement. So I am not taking all these things into consideration. I'm only considering the lift forces and the drag forces for the bubbles which is going to interact with the slurry. So this is how you set up the things. And as I told you earlier, what you need to understand the physics of the problem before proceeding to the actual simulations. So what you need to understand is you need to understand the bubble which is moving in the slurry, and it is encountering with the different kind of forces. Now, what are the forces you take into account? It's all depend upon your choices actually. Okay. So in this experiment, only drag forces and the lift forces are considered, and you have a two different uh, 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 forces, two different velocities. So this is an experiment. This is the simulations, which is, if you see how this bubbles, how this air is interacting with the water actually. If you see the different um, uh, if you can visualize this, you can see this how this air bubbles are interacting with the uh, with the water actually, and it helps you to understand how these bubbles, what are the different forces are going through these bubbles. So if you see this experiment, it is a rectangular column of width 20 centimeter and depth and height of 120 centimeter. So all these experiments are isothermal in nature, and you have a air which is being flowing from the bottom with the different velocities. Okay, so all these four walls, if you see all these four the walls which are there, which are holding the slurry, you have to give the proper input conditions to for that to try to actually simulate those things. And so the no slip boundary conditions are used at the walls, and at the outlet it is the pressure outlets, the gauge pressure is 0, and you have a turbulent intensity of 10% using the hydraulic diameter of 0.08, and basically using the turbulence is also coming into play. Okay, so these are all the And the important thing is, what are the solvers which you are going to use? The solvers mean what are the how you are going to solve the equations, and the solver means like how, what are the different factors which are taken into the account. So in this experiment, this is the Euler two-phase model is used to understand the interaction between the two phases, between the air and the water. Okay. So now if you see this, the result part of it. So what is the important thing is like how these air bubbles are interacting with the air. So when it interact with the air, what will happen? The slurry will try to there's a interaction between the bubbles and the slurry. So what we are trying to say is how the velocity of that bubble is going to be impacted. What is the impact on the velocity of the bubble when you have a slurry? So this is, if you see the two figures actually, the local vertical liquid velocity at supervelocity of 0.005 and the local gas fraction. Okay. So if you see, so the props, there are two different, so if you see the three different graphs, these are different locations in the experimental this thing in the domain, and at the three different locations the velocity of the liquid is find out how the velocity, the vertical velocity, the velocity in the upward direction of the liquid is captured, and it is drawn with respect to the time. So how this velocity of the liquid is the vertical velocity of the liquid is changing with the time. So if you see the three different color uh, graphs, these are three different positions, and at the superficial velocity of 0.005, how these liquid velocities are changing with time. And on the on this figure second, it is the volume local gas fraction at the looks. How much the gas is there at a particular location with the time actually. So it means like what is the percentage of the air in the whole volume at a particular instant, at a uh, particular uh, superficial velocity. So it gives you the insight. It gives you the insight how this velocity of the slurry is changing, how the velocity of how the interaction between the fluid and the bubble is taking place, and what are the different. So if you remember, we involved only the drag forces and the drag model we have introduced. So drag model and all these things depend upon the velocity, the different upon the relative velocity between the bubble and the slurry. So it gives you, so based on these reports, based on this data, we can actually see what is the optimum velocity, superficial velocity at which the maximum reactions takes place, or the maximum exchange of the species takes place. So all these things are there actually. When you do the CAD simulation, it helps you to understand. So different, now if you see the different velocities, if you see this is one of the at one particular superficial velocity you have this kind of data results, and on the other you have again, this is for the different superficial velocity and how these curves are drawn. So this again a vertical velocity of the slurry of the liquid at a particular time. You can see what is the velocity at a particular probe locations, at the particular locations. And again on the figure 4 is the local gas fraction of a superficial velocity of velocities at a different. So at a figure 4 is the local gas fraction again at a different superficial velocity. So in this whole experiment, as I told you, this is the actual setup for the experiment for the industry, and this same experiment can be simulated using the CFD analysis, and you can actually understand. So this is a very quite simple a simulation, but it gives you the insight of how the things takes place and how the reactions takes place, and what are the different governing parameters which are involved in this experiment. So actually you can now play with the different superficial velocity, and you can actually find out what is the how this interaction between the fluid and the between the bubble and the slurry is taking place. So of course you can involve a lot of other external, as I this you see only the lift forces and the virtual masses, only the lift forces and the drag forces are involved. You can also involve the virtual masses, well, your wall lubrication forces and the dispersion, turbulent dispersion, and then you see how these forces changes the velocity, vertical velocity of the liquid. So all these things are there which you can explore, and it gives you the, gives you the insight of all this type of experiment. So based on your understanding of the problem, based on your thinking, you actually implement those kind of forces, and you actually will come to know that how these parameters affect the experiments. Now, the same experiment is again is done again for a transient turbulent incompressible flow, basically. Okay, and in turbulent incompressible flow is done, and uh, using the multi-phase particular in-cell methods actually. So basically, in the earlier one, we are using the Euler model, and in this you're using the Euler-Lagrangian particle tracking methods. So now these are again the idea of giving you the glimpse of all this thing is to you have a different models which are existing in the CFD, but actually it is all based on your requirements. It is all based on your understanding the physics of the problems. So you have to understand what are the things which you want to simulate, and what are the different models which are available, and each model has got his advantages also, and also has got its limitations. So you have to decide which model or which solver which is going to be used for the accurate predictions of your results. So idea is to Euler-Lagrangian and Euler simulations. If you see these two models, these are two different models for the same applications. But of course, if you compare the results of both of them, they are different. Different in the sense because the way they are modeled is entirely different. The frame of references changes. In the Euler frame, you have a different frame, and you have Euler-Lagrangian, you have a different you analyze the forces in a different frame of reference. So if you see for the Euler-Lagrangian, it is basically you are tracking the particles in each particles actually. Okay, so earlier these particles, we are not concentrated about the particular particles in nature actually. So it was like you were all you are averaging everything, and you are seeing the results. But in case of the Euler-Lagrangian, what we are doing is we are actually tracking each particles. So if you see the velocity contours, you can actually see how this particular each particles, air particles, are distributed inside the column. And on the right hand side, you can see how this the velocity is distributed. So if you see there are small arrows which are moving in the upward direction and coming back also. So this gives you an idea, like the flow is actually is moving actually not in the uniform direction, but in the every direction it is moving. So, and it tells at which point you have a maximum velocity and which point you have the velocities are changing actually. So these two different models, though predicts the results, but the explanation of the results, the insight of the results are completely different in both of them. So the idea is to give you before introducing any CFD analysis, you need to understand the application. You need to understand the type of forces which are being implemented, the type of solvers which you're going to use, and then kind of uh, the basically understanding the physics of the problem before introducing any kind of CFD simulation. So if you see comparing the results again, earlier we have seen this Euler and Euler Lagrangian. So this is again the velocity of so two figures are there. Earlier one is the for the Euler and the figure which is in the below figure which is below is the Euler Lagrangian for the same position and for the same velocity, superficial velocity. So you can actually compare these, how these two different models for the same application, for the same input, for the same boundary conditions give the two different results actually. So if you see for the same superficial velocity of 0.25, you have a Euler velocity profile and a velocity distribution, and the below you have a Euler Lagrangian and the velocity distribution, how the velocity is changing with the time. So you can actually see, and then you have to compare these two results with the experimental values and trying to see which model is actually accurate for you and which model which is giving you the results which are close to your experimental results. The another example which we are going to take is application in terms of the uh, experiments in terms of the industrial use and industrial use in the renewable energy resource is the fluidized bed actually. So again, this what is this fluidized bed is there are different uh, uh, uses of it. It is used in the waste and the biomass, use of fluidized based combustion and gasification plant with steam turbine and gas turbine, multi-phase flow and pollution of fine particles had a wide application in the industry. It involves industrial fluidized bed processes ranges from the simple applications like drying, cooling, pneumatic transport of orders, and you have different kind of applications of fluidized bed in the industry and also in the field of the renewable energy. Okay, so again this is a quite simple setup, but again in terms of the industrial use, it has got a very significant role to play actually. So if you see the figure, you again have a gas which is being fed from the bottom, and the entire the column is filled with the particles actually. It can be a sand, it can be coal, it can be anything. And when the gas passes from these particles, it interact with the particles, and this is how the fluidized bed works actually. So again, I'll just briefly explain you how this important application of CFD, how the CFD is used to understand the fluidized bed. So if you see this application part of it, again, it is also used in the thermochemical battery for energy storage in solar thermal technologies. It is used in the solar energy. So before again setting up the case study for this fluidized bed, you on the left hand side, if you see, it is so this is the gas solid fluidization experiment, which is carried out in the 2D rectangular domain. The height uh, is uh, is almost 1 meter, and so height is 1 meter, but your fluidized bed will be of the height of zero point 0.7 meter. It means the bed particles the height of the particles which is filled inside the domain would be 0.7 meter, the width is 0.2 meter, the depth is 0.02 meter. And air is used as a fluidized medium, okay, with the diameter of the fluidized particle is 2.26 mm, and the density is the 2600 kg per meter cube in the solid phase. And then air is introduced from the bottom of the column using the uniform seed plate, and with the bottom region of 20 centimeter into 2 centimeter, and the superficial velocity would be 1.736 and 2.78 uh, uh, meter per second. So again, there's a two different cases where two different velocities of the fluidized of the bed, and you have number of cells actually. So number of cells is 20 in the x direction, and 4 in the z direction, and 70 in the y direction. So these are the number of cells, where this number of cells means there were these equations of equations, governing equations will be solved actually. So this is a small setup again. So before again starting, just will briefly go through the governing equations. So what are the governing equations? So again, as I told you, what are the equations, mathematical equations we are going to solve? So if you see this, the equations are the continuity equations of two different phases, the alpha 1 and the alpha 2. So alpha 1 and alpha 2 are the two different phases. One is the particle phase and another is the air phase. And then you have the momentum equations. Then again, momentum equations, you have two different momentum equation for the two different phases, and it involves the different again it involves the different stresses. So if you see, these are all the momentum and the continuity equations which are solved along with the different forces. So the pressure gradient and the bulk viscosity, everything, if everything is there in this equations, it involves everything. So basically, this is the governing equation. So every series simulations, you need to understand what are the main governing equations which you are set of governing equations which you are solving. So here only you introduce your ideas. If you want to introduce any kind of forces which is not there in the equations, you can actually add those forces in the equations, and then you see how this things works. So this is the simulations where this air is full, air is coming from the particle, is blown from the bottom, and this is how these particles are basically getting dispersed in this domain actually. So it's quite interesting, and it's so alpha particles. If you see it, it means the particle distribution, how these particles are distributed. Okay, so you have certain kind of velocity which is being fed from the bottom, and then because of this air, this particle moves in the upward directions, and how these particles are getting dispersed. So again, as I told you, this air will interact with the flow particles actually. This will interact with the particles. Now again, what are the forces which you are going to take into the consideration? So that is very important, because again, this is the interaction of the air with the particles, and how this air and the particles interact. What are the forces which are there, which is interacting with each other? That is very quite it's quite important. So those forces can be drag forces, those can be lift forces, those forces can be the elastic collision between the air, between the two particles. It can be interaction between the particles and the wall of the domain. It can be an interaction between the wall and the bottom wall. So all these things plays an important role to understand the whole simulation. So when you write down, when you try to understand, you just think about all these forces and you understand. And these applications actually helps you to understand how the different velocities, if you change different parameters, changes the results actually. If you change the size of the segment of the particles, if you change the velocity of the superficial velocity of the air, if you change the density of the particles, all these things will be changed. And this distribution of particles in the domains helps you to understand the interaction between the air and the particles. So again, if you see, this is the velocity of the particles at different locations at different locations at different superficial velocities. Okay, so this is a particular point where the probe is inserted, and then you see how the velocity of the particles is changing. The vertical velocity is changing with the superficial velocity, different super velocity. So, and it helps you to understand, again, it helps you to understand how these things, how the particles and the air interact. So if you see these kind of easier experiment, the simple experiment I have chosen to to understand, to help you to understand the importance of CFD, the importance of the doing the simulations before doing any kind of experiments, and to motivate you to explore this area, to understand your problems. It may be different from what I am showing, but of course you can implement those ideas, implement those kind of things in your problems, in your understanding of the engineering systems and problems, and try to see the problems in a different way. Now this is the another case study where you have this air bubble particles, which is used uh, in various industrial application. Actually, this is one of the experiment which is related to nowadays everywhere actually. So the application part of it is like you have a bubble which is there in the water. So in case if you might be aware with the cavitation process, in which the turbine blades get corroded because of the bubbles which is produced, which is hit by which is the bubbles which hit the surface of the turbine and and burst, and because of that a low pressure area is created, and the air hits the surface and corrodes it. So one of the most important application of these kind of bubble formation inside the water is really it helps you to understand these kind of phenomena like cavitation. And apart from that, there are several other applications which you have nowadays you have a bubble cleaning process in which the water bubbles are used for washing machines actually. So if you have not seen those kind of things, it's like bubble is being imparted on the surface of the surface to be clean, and these bubbles burst and it creates the low pressure region, and it helps in cleaning. So this is the another application of the bubble application. The another application of this bubble is in the destruction of the kidney stones. So people who are having kidney stones, along with the ultrasonic technique, the bubbles are used to destroy the kidney stones which are produced inside the kidney. And this is again a very important and very significant role of the bubble inside the bubbles in the field of medical sciences. So one of the most leading and most important research are nowadays are using the bubbles to deliver the medicine inside your body actually. So the idea is like bubbles, because of its nature, it flows inside your body, and these bubbles will be carrying some kind of medicines, and these bubble will carry those medicines and travel through your body to a particular area where this medicine will be transported, or it will be given to that particular area. So this is again key area where there's a lot of research is going on to understand how these bubbles are traveling inside the liquid, and what are the different factors which are there to which helps you to what are the factors which involves the transportation of these bubbles. So if you are aware of these the phenomena, the physics behind the bubble, it's quite simple. Because of the buoyancy, the bubbles rises in the column of liquid, and these bubbles are actually very important if you understand the heat transfer process, if you understand the mixing process. So all these bubbles are quite important when you have an energy interaction. It carries the energy from the one part of the fluid to the other part of the fluid, and it plays a very important role. So the idea of this simulation is to basically very the understand the fundamental nature of these kind of flow, actually, how this flow takes place and how this bubbles rises takes place inside the liquid, and what are the forces which are acting on it, how these bubbles and the different fluid interacts, and what are the means by which you can actually controls the flow of this bubbles inside it. So this is an experiment which is done again on the open form, and this is a very special type of uh, methods which is called the volume of fluid method, in which you use the kind of volume of fluid, means like you use certain kind of marker cells actually to mark out the fluid and to separate the two regions of the fluid actually. So this is one of the very important tool of in the CFD, the volume of fluid method, which is used to explore the fluid interaction and the fluid surface interaction between the different fluids. So multi-phase fluids can interact with each other, and to see how these interact, this volume of fluid matters is quite handy. So here this interform solver is there in the open form, which is being used, and you have this transient turbulent incompressible flow is used. So if you see this domain, basically domain of size is 30 mm the x direction, and height is 70 mm, and then inside this domain, the bubble diameter of 6 mm is introduced, and everything is filled with water. And if you see again, if you discretize the domain, the number of cells is 80 in the x direction, and you have number of cells of if you have a number of cells of 200 in the y directions. So this is again, as I told you, the number of cells are very important. It's also depend upon your system, how robust your system is, or how because finer is the mesh, the more you're able to resolve the forces more. Uh, uh, you will resolve the forces, and you are able to see the results more accurately compared to the coarse mesh. So, but again, the finer mesh requires the high computation power, and it takes time also. So depending upon your ability of your computational power, you can decide the number of cells. But of course, it's going to affect the results. So basically, you have to use very widely everything in terms of in terms of your computational power also, and also in terms of the your capabilities. Now, if you see again, the governing equations for this experiment is basically, again, we are solving the continuity equations, and you have this Weber-Stokes equations. And along with that, if you see, you have two type of phase actually, the primary phase and the secondary phase. So basically, the equations are only solved for a single phase, not for the two phases. So and at the interface, all the cells which is at the interface is having a value of either 0, or at the interface you have a value of between 0 and 1 actually. This is how the volume of fluid works. The volume of fluid works where, like, you cells in which all the fluids cells which is fully filled by the phase 1 will be given a value of 1, and the cells which are not having the phase 1 will be given 0, and at the interface you'll be having the value between rising between the value of 0 and 1. So you have this continuity equations and the Weber's equation which is solved, and then the motion of the interface, how the motion of interface is tracked, is solved by using the advection equation. So this is how your equations are solved at the interface, and again it is redesigned and then resolved, and then again new value of the alpha and the viscosity is calculated, and then again based on that your tracking of the interface is taking place. So if you see this experiment, this is the rising of the bubble which is taking place, and then it is, so deliberately I have allowed this bubble to deliberately I have allowed this bubble to collide with the wall actually, and then see how these bubbles actually interact. So if you see a lot of diffusion, you will see this mass which is being distributed, and then again you see how these things are taking place actually. So you can do this kind of a small experiment at your home also, and trying to see whether these kind of simulations are actually actually predicting the results which is there or not. So it will help you to fundamentally understand how this process are taking place. So if you see the behavior of the bubble, how the motion of the bubble is taking place, how it is rising. So now you can, once you are used to these kind of experiments, you can actually understand how these bubbles interact, and how these bubbles interact when you changes the fluid. You can change the nature of the fluid, you can change the nature of the forces acting on it, you can change the size of the bubbles, and basically all these things will help you to understand the forces, the understanding the mixing process, and how the energy is being carried away by these bubbles from the one position to the another position. So this is definitely going to help you. These are the fundamental fluid problems which will give you insight of how these things takes place. So briefly, this is the bubbles at the different time locations, at the location at different time actually. So if you see how these bubbles are rising, and in the middle figure, if you see, this is the velocity profile, how the velocity and the pressure of at bubble at different time, it is shown here actually. So how, when it is rising in the liquid, how it is moving upward. And if you see, it's quite interesting to see how the velocity profiles looks like. In the middle figure, if you see, these are the velocity profile of the bubble in around the bubble. If you see where are the region where you have a very high velocity and a high pressure, or in the left and the rightmost part is the is the pressure distribution, how the pressure is distributed. So it helps you to understand, if it helps you to understand how the different forces, are acting on the bubble, and what is the region where these forces are maximum, where is it is minimum. And also apart from that, it helps you to understand how the pressure variations are there actually. So if you see, it's quite interesting to find out how these bubbles behaves in the liquid at different instances. And these fundamental experiments actually helps you to understand how you are going to use these results, these experimental values to your use. It can be used, as I told you earlier, this can be used for the transportation of the medicine in your body. It can be used for the destruction of the kidney stones. It had got several applications in the industry where you have a bubbles. It can be so. In this case, it is only the water, but in your industry, it can be a different fluid, it can be a different bubbles, it can be the instead of air you can have a hydrogen, you can have a different kind of uh, gases, which is the bubbles of which being produced inside the column. And then you see how these different gases and different liquid interacts with each other, whether they are going to follow the path or not, how it is moving, whether it is moving in the upward direction or maybe it is deviating from their path. So everything you can actually see once you are able to simulate this fundamental flow. So this is a brief idea of the velocity, the terminal velocity, which is achieved by the bubble at different time locations actually. So this is giving me an idea how the velocity of the bubble is changing with the time. How the tip, so velocity is taken at the tip of the starting tip of the bubble, and then with the time the velocity is changing actually. So as if you see, it rises sharply with the time, and then after some time the velocity fluctuations are very small in nature. So it means it attains the terminal velocity, the steady velocity. So this is just again a kind of results which you can produce when you do these kind of experiments. Now another important application of this is in the field of the core annual flow. So basically, when you talk about the energy, renewable energy, or energy in terms of petrochemical industry, so where you have this products which is produced at the refinery, or if you see any of the refinery, what they do is they have a crude oil which is being given to them, and they what they do is they process this crude oil, and then these crude oils are refined, and then it is transported to the different parts for the uses. So one of the application of in the CFD is the core annual flow actually. So what does this core annual flow means? Like, you, in case if you have a very high viscosity fuel, okay, and if you want to transport those oil through the pipelines, what happens, because of the very high viscosity, your pumping power increases drastically. It increases very high because of the high viscosity and high drag force which is there with the fluid and the wall. So now the idea is to reduce this drag force. So what is the idea is, like, you enclose that fluid with the water actually. So what it means, like, in the pipe, the fluid will be the heavier fluid will be going into the center, and the it is surrounded by the water. So now what happens, the core, that is the center part, it is filled with the fluid, with the liquid which you want to transport, and then you put water around the fluid, actually around the liquid which you want to transport. So the water is always in contact with the surface of the pipe. The oil is never in contact with the wall. So because of that, what happens, there is only a water and the pipe which is interacting with each other, and in beneath and inside that water you have the fluid, which you have the oil which is flowing. So, and then when you do these kind of uh, uh, these kind of things, to drastically reduce the pumping power, because this time you are not pumping the oil, but you are pumping the water, and the drag force between the water and the pipe is very less compared to the drag force between the oil uh, and the pipe surfaces. But of course, it is not that easy. I mean, because if anything happens, the water will mix with the mix up with the oil, and your everything will be spoiled. So, everything will be spoiled actually. So the idea is to presence of water in the surrounding reduces the drag present at the pipe walls, reduces the cost of piping, and it also save energy. Now, how it is possible, because these are immiscible fluids, actually the water and the oil are immiscible, and they don't mix with each other, provided you have to supply the correct pressure, correct flow rates, and the certain flow parameters which you need to maintain. So these are the, this is a very important application in the industrial, where you can save a lot of energy by transporting the oil using the core annular flow methods, where the oil is at the core and it is surrounded by the water at the annular. So of course, the flow parameters and everything is very important actually for this kind of transportation of oil. So in case of if you in case of any problems in these kind of flow, it will mix up, and your system will be down actually. So if you see, the idea is to have a core which is the oil and surrounded by the water. So these kind of pipe flow, if you see, these are a perfect core annual flow. You have a core which is the oil and surrounded by the water, and then you have a oil drops. Actually, oil drops means you have a water, and you have a small drops of water which is being transported, and then you have a slugs of oil in the presence of water, and then you have this bamboo shape kind of oil which is there at the core and then surrounded by the water. So these kind of different type of flows which you have must have seen in and around you, but you have not not seen it in that way to understand these. This can be a kind of way of transferring the oil in a industry actually. So what does it mean? This is one of the important aspect of this kind of flow is the stability study actually. First of all, it has to be once you feed your water and the oil together, you need to make sure that the fluid do not mix with each other. So that is the prime most concern in this kind of flow, where you should not mix any kind of oil and water with each other, and that can only be possible when you give accurately the amount of the amount of the amount of flow rate, the pressure, and the viscosity, and the other flow parameters has to be uh, to be analyzed properly before starting any kind of transportation. So this is one of an experiment in which I did, and we performed kind of experiments, kind of simulations, where uh, we did some stability analysis of uh, vertical laminar core annual flow using volume of fluid methods, and again open form, and we did for the 3D as well as for the axisymmetric cases, and we try to analyze how these cores are stable. Of course, we did a lot of experiments where we failed uh, to to achieve the desired results. Sometimes the core and the oil is mixing, and all these things can happen. But gradually, when we kept on doing all these kind of experiment, we trying to improvise every time, and then we finally did experiments which is giving us the results which were comparable to the experiment values which are existing in the nature, and we were able to perform these kind of experiment and trying to, and the stability of the core and the core aeroflow is achieved actually. So the linear stability analysis of vertical laminar core airflow is performed, and growth rate of the amplitude of the perturb interface is compared with the experimental result of the existing literature. Then, so the idea is to take the small portion of the pipe actually, try to take the small portion of the pipe, and based on the small portion, you see the stability in that small portion, which is equal to the wavelength of the fastest growing wave, and then you see how these waves at the interface grows actually. If that growth rate is not linear, if growth rate is not appropriate, the mixing can take place, and there's a problem actually. So the idea was to simulate those things, and a lot of research has been done before doing these kind of simulations to understand the stability analysis of these kind of flows. But of course, this has got a very wide applications in the industry, in the transportation of the fuels, transportation of the heavy fluids. So basically, if you see this core and annular flow, there has to be, as I said earlier, the velocity profile, and the velocity profile is to be very precisely given actually. It's precisely to be before the experiment, it has to be given the perfect velocity profiles. Now these profiles are taken from the existing literature where the people have done a lot of experiment, and then try to find out how this how these non-dimensional numbers are used to define the property. Non-dimensional properties are used to define the velocity profiles. So if you see, there are different non-dimensional numbers involved in the velocity profile that involves the m, a, k, j, and then zeta. So these are all the ratio of the viscosity of the oil and water, then the radius of the pipe, and the interface. Then you have a pressure gradient and the gravity, and then it involves the surface tension, it involves the density, it involves the density of the oil and water, and of course the Reynolds number, which is the function of the density, the velocity, and the radius of the interface, and the viscosity. And you have a central line velocity of v0. So all these parameters are taken from the existing literature where people have done a lot of experiment on color and flow, and based on that only they have come up with these kind of equations. So once these equations are known, you implement these equations. You have to put these equations into the simulation, and then try to see how it is done. So what it is, so once it is set up, you at the interface, you give some kind of small amplitude. So the idea of the linear stability theory is to see whether this small amplitude will rise with the time or not. So this is an idea. In this simulation also, I have given non-dimensional amplitude of 10 to the power minus 3 introduced at the very start of the simulations, and this is the equation for the initial distribution wave, the sinusoidal wave of the initial non-dimensional 10 to the power minus 3 is being given, and then uh, the moving frame reference is used to increase the speed of the simulations, and the grid size of 128 and 128 is used, and of course, because we are trying to simulate the pipe, we are taking the small section of the pipe to see the wave formation, and all the periodic boundary conditions are used at the inlet and the outlet. And basically, then once you develop these kind of simulations are done, then you, based on the different parameters, actually the linear stability theory, based on the linear stability, the final and the once you start the simulations, the amplitude will grow gradually with the time, and then after some time the amplitude will be steady in nature. It means the flow has been developed and all the forces are in equilibrium with each other. So in this simulations, you have a pressure gradient which is acting across the ends. You have a velocity profile which is given to the core and the interface, and then you have a non-dimensional amplitude which is being fed at the interface. And then you see how these non-dimensional amplitude or the small amplitude of disturbance which is there at the interface grow with the time. So now if you see this analysis, this is the core, left hand side is the core deformation, which is core deformation mean how this oil which is being deformed because of the motion of the oil. And on the right hand you can see actually how this waves are being produced at the interface. So this quite helpful in understanding how the deformation of the core takes place, and how this uh, uh, the waves produced at the interface is there. So if you see this kind of a bamboo shaped waves are produced, and these if you see these oil and the water as actually distinguished with each other, they are not mixing with each other actually. So this is one of the simulation results which we have done, and we have seen this there in this. So this is again the this is how the waves are produced at the interface. And if you see the cross-sectional view on the right-hand side of the figure, this is how the oil, which is there inside the core, and it is, even though the flow is taking place, the core is not mixing with the water actually. If you see, it's quite interesting to see how this oil and water are stable in nature, and they are not mixing with each other actually. Though there are deformation of the core which is taking place, but they are not mixing each other, and stability of the core is maintained actually. So this is again, it's quite interesting because this is one of the revolutionary area where we can actually which people have used it in different countries, where you have a long pipeline uh, uh, where you want to send those heavy fuel, uh, and also reduce the cost of the pumping. So of course, it is very it is something which is uh, very important to operate these kind of uh, machinery with the precise understanding of the flow parameters. Otherwise, it will be very difficult to maintain the stability of the flow, and the core and the oil will mix, and your system will be shut down. So these are the important. If you try to do these kind of experiment in your lab, it would be very tedious, and it would be very difficult, because you have to take this whole heavy fluids fed into the pipe, along with all the apparatus and everything. So it's quite difficult, and it's quite tedious also to do these kind of experimental things. But of course, with the use of the CFD, with the use of the available codes also, you can also develop your codes also, and then you can actually see how these things are uh, can be performed, and actually you have an insight of all these kind of flow. So this is again the axisymmetric case which I was discussing. So here this is uh, in this experiment, this small portion of the pipe is taken, and then at the interface you have a small disturbance of 10 to the power minus 3. And if you see how these waves are produced, actually how these waves are developed with the time, so you can actually see how these waves are produced at the interface and how it is moving along the flow actually. So it's quite interesting to see. If you see this figure again, the blue part is actually the water and the oil part, and the red is the red part is the oil actually. So if you see how this with the time how this oil and the water are moving with each other, but they are not mixing with each other. So it's quite interesting to see. And of course, again, you can actually predict the different kind of forces which is acting on it, the different kind of pressure profiles. And on the left hand of the figure, if you see, this is the velocity which is developed at the interface. So you can actually see how these velocities the velocity is produced at the interface, and it helps you to understand the wave stability. So this is one of the small wave, and then you can do experiments, you can do simulations with a different kind of wave profiles. Instead of sinusoidal, you can have a different wave profile, and you can also give the different non-dimensional or dimensional amplitude of the wave, and you see whether these waves are actually stable or not. So again, if you change the flow parameters like the flow rate or the or the pressure gradient acting across the ends, you'll have a different results. And it's kind of an experiment where it will help you to understand the transportation of the heavy fuel oil. So basically, once your code is validated, you can actually change the different uh, parameters of the flow. You can change the viscosity. You can use the different type of oils, and to find out whether these oils, when transported, will be stable or not. So this an important aspect of this experiment actually. So the key feature of these experiment is, of course, you have to rely on the mathematical equations which are there. You have to closely observe the mathematical equations. What are the things which is being taken care or not? Whether the surface tension is taken into the account, whether capillary forces are acting on it, whether the pressures, whether the pressure, whether the buoyancy forces, where the gravity are taken into the account or not. So before doing all these kind of simulations, you need to understand what are the set of governing equations which you are solving, and based on the requirements, you can also change your experiments. You can change your set of equations and boundary condition and see the results whether they are matching with the existing literature or not, or whether you are getting the desirable results or not. So one of the this if you see this experiment, the small amplitude is given, and then when you see this how this waves are changing with the time actually. So this is one of the way where you see this, where you do the stability analysis. Then you compare the growth rate. It means the growth rate of the waves is compared with the existing literature, and of course with the literature, with the open form, and also with the DNS done by the Renade. And if you see this, all these results are closely in agreement with the theoretical growth rate actually. So if you see the figure, it is the logarithmic amplitude and versus the non-dimensional time, and this growth rate are compared actually. So this blue dots are actually the simulations results which I have performed, and the red straight line is uh, basically the theoretical growth rate which is being done, and you have a another results which is obtained from the open form. So it's quite evident that the results are in line uh, with the linear stability theory, and it's matching with the linear stability theory. So this is one of the important thing which we need to understand the simulations, the power of CFD to understand the complex cases, which involves a lot of insight, actually, a lot of values, lot of experimental data. Okay, so it can gives you the results which is very comparable compared to the experimental values. Now, I would just like to conclude here, and so we have been talking about the applications of the CFD in the field of renewable energy, green technology. So there are n number of examples which are there, which is not possible to include right now because of the time constraint and all. But of course, there are a lot of things which can also be explored, uh, which can also be explored, and also I would like to encourage all of you to to involve at least some part of the simulations in your experimental analysis, in your teaching, in your research, so that you'll have at least an idea of how these things happens, and you can actually do the small uh, uh, simulations before doing any kind of experiments, or you can validate some theoretical results also which is already existing, and it will help you to understand the things also. And the people who are involved in teaching, they can also involve these kind of simulations in your teaching also, to demonstrate, to validate the already existing laws to the students. And student, of course, they will also be fascinated to understand the use of CFD. Nowadays, the people are more familiar with the code, C programming, Java, Python. A lot of things are involved, and of course, there are a lot of commercial codes are like ANSYS. Are these things are available, which is going to give you beautiful picture of CFD, which will help you to understand the complex nature of problems in a simplest way, and definitely going to help you in teaching and all. But apart from that, as I told you, it all depend upon the limitations. It depend upon the computational power, the and sometimes it may happens that the right mathematical models may not be available to replicate the physical process or the phenomena which you want to replicate. So in that case, you have to write your own code. You have to come up with your own ideas. You have to come up with your own mathematical equations, your own way of solving those things. And of course, there is no limit. Actually, you can always explore those codes. You can always, there are a lot of codes uh, which are which are openly available to explore. Open form is one of them. You can explore. These codes are absolutely free. The setups are already free. There are a lot of people who are discussing about all these things. You'll have different case setups. You have different tutorials. You can go through all these things, and definitely will help you in understanding the simulations. And it has got, yeah, as I told you, it has got some limitations in terms of computational power, the inability of the mathematical models, and of course, sometimes when you use very large complex geometries, it may not be feasible to do the whole analysis. So what in that case, what you do is you try to segregate, you try to divide the domain into a smaller parts, do the analysis, and then it will help you to understand the phenomena. So, and of course, it is the use of CFD is not limited only to the green energy or the renewable energy. I have just given you the small. The idea was to give you the small to demonstrate small simulations to understand that how these small things can be used in the field of green technology, in the renewable energy, and the other areas. So that is the main idea behind all these things. So with this, I would conclude this presentation, and I hope you people would have listened it and definitely implement in your research and teaching. So thank you so much.
Thank you so much, sir. And after so Abhishek, can you Abhishek MS, please conclude the session.
Yes, sir. Sir, before concluding, like I have one small doubt, sir.
Yeah, tell me.
Sir, like comparing to this one, like what say block mesh and like importing the file from what to say ICM, which is better, sir? Like doing the .msh from the Fluent that ICM software is better, or like using the open form
See,
block mesh is better, sir?
see, it's all depend upon the user actually, which he is comfortable. Of course, the block mesh involves certain bit of uh, certain bit of your coding, and slightly in my experience it's all depend upon the user. Sometimes people are comfortable with the block mesh. Sometimes people do the meshing in the answers and then import it to the open form. So it's all depend upon the user in which you are comfort, I mean the way you are comfortable with. So, and again I would say that these codes are actually nowadays are very flexible with all these kind of, you can have the party software for your developing your mesh, and then you can import this into the open form, or any kind of software codes actually which are available. So it's all depend upon like in which by I mean comfortness of the user actually. So I hope it is clear now, Abhishek.
Uh, yes, sir. Yes, sir. Like thank you, sir, for like taking out like time from your busy schedule to provide us with the valuable information and give information about approach to the research field of like how to use the open source code. On behalf of all the coordinator, myself, and a participant, I would like to thank you for your lecture and thank you, sir. Thank you for your
Thank you
time.
so much to all of you, and thank you to Dr. Savin Kacha for giving me the opportunity. Thank you.
So thank you, sir. Thank you so much. Dear participant, after the lunch we can meet. The next session will start from 2:30, and we will meet at 2:15. So thank you for everyone. Thank you. Hello. Hello. I'm audible, anyone?
Hello,
Yeah.
sir. Yes, sir.
So,
Yes,
Audible, sir.
audible, sir.
good afternoon. Yeah, good afternoon again. Dear participant, our third expert, technical expert, Dr. Satish Kumar, sir, he joined shortly, and he is associate professor in Department of Mechanical Engineering, NIT Jamshedpur, and uh, he joined us shortly. Just wait for 2 3 minutes, then he join. Hello. Hello.
Hello, sir.
Yeah.
Hello, sir.
Hello, good
Good
afternoon.
afternoon, Satish sir.
Good afternoon, Sabendra
Yeah.
ji.
So, dear participants, our third expert, Dr. Satish sir, Satish Kumar sir, is joined us. So, I am welcome to sir. So, I am requesting to Mr. Abhishek Abis, please introduce sir in brief to the participants. Mr. Abhishek Abis.
Yes, sir. It's my pleasure to introduce you, sir. Good afternoon, sir. Dr. Satish Kumar is presently working as a associate professor in the Department of Mechanical Engineering, National Institute of Technology, Jamshedpur. Currently, he is holding the post of faculty in charge admission, controller of examination, chairman of Institute Publication Cell, chairman of Institute Newsletter at NIT Jamshedpur. Dr. Satish Kumar obtained his bachelor and master degree from the Department of Mechanical Engineering, SPNIT Surat in 2002 and 2004. He has completed his PhD under the supervision of Professor B.K. Gandhi, Department of Mechanical and Industrial Engineering, IIT Roorkee, in the area of solid liquid flow in 2014. His research interests are rheology of slurry flow, computational fluid dynamics, erosion wear, flow phenomena of solid liquid flow in a pump and pipeline. He authored and co-authored over 70 research articles in SCI and 33 in a Scopus Index journal in the field of multiphase flow. He supervised 8 PhD and 55 MTech.
Hello, Abhishek. Hello. Hello, Abhishek. I'm audible. Hello. Sir, I'm audible, sir. I'm audible. Anyone?
Yes, you are audible.
Audible, sir.
Okay.
Audible, sir.
Some technical. Abhishek MS, your voice is not coming.
Audible, Sabendra.
Hello. Hello. Yeah, sorry for network problem.
Hello, sir. Am I audible, sir?
Yeah, Abhishek, audible.
Yes, sir. Sorry for the inconvenience, sir, due to network problem. Uh, Currently, 3 research projects is ongoing. His life member of IST, ASME, NSFME, AEENG, Institute of Engineering, NITTST, etc. We are very proud to have you with us, sir, to listen to your lecture. A warm welcome to you, sir.
Thank you, Abhishek, and thank you, Sachin ji, for invitation me in your ATAL program. So you have given the share option, na? Yeah, just I'm going to say. This is visible?
Yes, sir, it's
Yes.
visible, sir.
Sir.
Okay. So, dear participants, uh, thanks. First, before the starting of the title, I will discuss with you regarding the very good title of the ATAL FDP program, Green Technology and Sustainable Energy. You have attended the so many lectures also. Shivam, just एक बार आना. Sorry, just yeah, Shivam. एक second. Okay, I am audible now?
Yes, sir.
Yeah. So today I will try to discuss the some something with the performance of integrated solar collector with the nano particle enhanced PCM based thermal storage system. So in my topic having the, you can say, three component. One is solar collector performance. Second is the PCM based, the phase change material, and PCM thermal storage system we are enhancing by using the, nowadays nanoparticle are the very common the things for enhancing the heat transfer rate or enhancing the workability of the fluid flow system. We are using the nanoparticle. So in my presentation I will try to discuss one uh, solar collector performance with the addition of the, you can say, with the addition of the nanoparticle in with the application of thermal storage system. As you know, as per the your topics, you have the the different form of the energies. So in conventional form of energy basics, India, you can say, India power, in Indian power sector, you can say, governed basically with the coal thermal power plant. So coal thermal power plant plays the very important role, you can say, for getting the electricity. Approximate 60%, the contribution you are getting from the coal. Then rest of the things you are getting from hydropower, and some extent you are getting for petroleum product also by using the cogeneration, or you can say oil based thermal power station, gas turbine, the things. Some contribution you are getting nuclear, from the nuclear also. So about 18% of the energy you are getting from the nuclear. Solar contribution is today also very less, due to some disadvantage we will discuss here. About 7 8 or 8% contribution you are getting from solar. Modi government has taken the large initiative for, you can say, uh, explore the solar thermal stations, also different application of the solar power in the form of the solar collector. Uh, so these are the and hydropower stations also. Hydropower contribution is also about 7.5%. So when we are categorizing the energy, then you can say conventional source of energy and the non-conventional source of energy. So first my question is, as you know, in northern region is totally in, we are living in Jharkhand, you are in Manipur. So coal we are getting very easily, and the maximum, you can say, thermal power station, maximum power you can say you are getting from the coal. So what is the drawback, why we are not going you can say, for continuing the production of the power from the coal? One reason, the uh, coal, you can say, this is a conventional source of energy, so you cannot once you have used, this is finished. But what are the other disadvantage? What are the environmental impact you are getting for the, you can say, by using the, you can say, coal in thermal power plant? Anybody having the idea? What are the other impact we are getting from the coal thermal power plant? Anyone having idea?
Environmental
Anyone can
pollution.
say? Yeah.
Carbon emission.
Yeah, one is the CO2 emission. This is the one byproduction of. Second, so in any conventional fuel, you will get the carbon. Yeah. Other disadvantage are in any environmental the things.
They
I
are
hope
limited.
that I have, we are the mechanical engineer. As we know, Indian coal having the very high ash content. In Indian coal, approximately 40%, 45%, you are getting the ash content. So very high as content you are getting in coal, and one thing is the CO2 carbon, you can say, emission. But due to high as content of the coal, when you are burning the coal in thermal power plant, then large amount of the fly and bottom ashes, coal ash are produced. And problem is to, this is the picture, and approximately more than 60% electricity you are getting from coal, and day by day your need is increasing. So coal amount also increasing in your thermal power plant, then you can increase your power production. So by increasing the quantity of the coal, more amount of the ash you will produce. So problem is how to tackle the ash in your the thermal power plant. So what they are doing, in some extent, government has from 2009-10, government has taken the a large number of initiative to utilize the ash in different form. And as you know, in buildings, in roads, also you are in different form, you are using the ash. Even in cement, approximately 60% contribution you are getting the ash, because fly ash, finer particulate of the coal ash, having the very good property of the pozzolanic nature, and this contribute uh, mm, silica and other elements. And due to cementing property, pozzolanic property, this we are utilizing in the form of the cement. But approximately 30%, sorry, Sivan, approximately 30%, 35% as currently you are using, you can utilize. The problem is how you tackle again 65% of the ash. So what you are doing, if you visited you have visited the nearby the thermal power plant, then the ash pond, if you visit, then you can see the ash pond, large, you can say, uh, outside the thermal power plant. uh, uh, you can say you are transporting the ash with the help of the water. So what happened when you are transporting this ash with the help of the water, then this ash, mineral elements of the ash, you can say, trace down in your the water. And nearby the rural areas, people are using this water, and this was also get the affected by environmental hazards, because the very others as per the Bhabha and other uh, regulatory authorities, day by day they are visited nearby the thermal power plant, and by taking the sample analysis they found that the nearby the thermal power plant region persons are, you can say, highly uh, 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 affected with the, you can say, mineral contents. So these are the things is. And other reason also, we are moving in the green technology by using the solar and hydropower plants. But issue is in you by using the hydro or solar thermal power station is to uh, initial cost and how you can get the continuous, you can say, form of the energy, or how you can get the regulate the energy. So here thermal storage system play the very important role, because solar collector either you are utilized in daytime or where you are getting the sun when the efficiency is very high. But problem is that where when you are not getting the sunlight, then how you can operate the things. So this is the again thermal storage system plays the very important role to make the device for continuously utilizing the solar energy. And we have also, and in Modi government has taken the large of initiative even in Gujarat, near the uh, uh, whole Narmada river or any other river, I don't know the name, whole passage totally, you can say, uh, are taken by the solar panels, and large amount of the solar is producing in the Gujarat. Government has taken the other initiative also for making the solar buildings and other things. So I am not going to discuss in detail. So this is the one discussion why we are not preferring the coal, and we are shifting from the coal to the either solar thermal power station or hydro power station or renewable energy sources. So this is the one high and scientists and in, you can say, CSIR labs and other laboratory scientists or ITs, we are also doing some work for doing the work how to convert the high as coal into the low as coal, so that when you able to convert the high as content coal to the low as content coal, then your problem approximately up to some level you can solve. So by using the some chemical treatment or leaching technology, we are converting to highest content coal into the lowest content coal. So this is the one part. Then comes our solar collector part. So solar energy efficiency, energy production, and energy security is an important component of the public and economic development. Solar energy is currently the most consistent alternative sources of energy. Earlier days, we have used the solar energy is only, you can say, utilized in where you are getting the regular sunlight. But today, solar energy is very popular in all the, you can say, public uh, offices. You will get the solar panels, and in another initiatives in rural areas also many things you will get solar light and other things governed by the solar energy. So photovoltaic systems can change the solar energy directly into the electricity, which can be stored in the battery form. And other form of the solar system absorb the solar energy, converts into the liquid, into the working fluids, and flow continuously into the form of tubes, just like in solar collectors. So flat plate collectors is the, you can say, very common and very simple collector that it convenient, and this is a very cost effective, very cheap you can get, and fulfill your needs. So we have used the solar collector with combined, you can say, thermal storage systems in our investigation. So since solar energy is unstable during the day, storage of energy is essential to use the energy effectively. That's why storage is very important. As per the need you can utilize. So current heat is stored in a reasonable temperature in the thermal storage systems, and you can say most of the low temperature application use the water as a storage medium you can utilize. So you know, the two type of the thermal storage system we are using, we will discuss later. One is sensible heat and second is the latent heat. So latent heat storage system is a very new and emerging technology that has attracted a lot of attention recently due to low temperature variation and having the very small size and small storage applications also. So this is about the introduction of the solar plate collector as well as the thermal storage system. So thermal storage system we can define as the thermal storage system correct the mismatch between the supply and demand of the energy. So according to the our needs, by using the solar flat plate collector, sorry, solar thermal storage system, we can utilize the energy. And as per our the requirement, as per our the, you can say, variation of the input or outcomes, we can change the things. So thermal energy systems involve three main steps. One is called the thermal charging, thermal storing, and thermal discharging. So benefits of the thermal storage system is to increase the system reliability. So to reduce the peak of the energy generation. So increase the generation capacity also. The excess generation available during the low demand period can be used to charge the thermal energy storage system in order to increase the effective generation capacity during the high demand periods. So the results of a higher load factor for the plants helping the generate energy in a stable way. Also, we can reduce the cost of the generation. So seasonal demands can be matched with the help of thermal energy storage systems, and synchronously we can upgrade the things. So this is about the thermal storage system. Different type of the thermal storage systems we are utilizing for the different purpose in general life also. So in hydropower stations, pump storage type of the system we are using. Batteries very common in photovoltaic cell. Batteries you are utilizing as a thermal storage system. Superconducting magnet energy storage systems also utilizing for store of the electrical energy. In IC, in you can say in engine and automobile vehicles, flywheel you are using as a energy storage device. Is so flywheel also energy storage. Regenerative type of the fuel storage systems also utilize. for the store the energy, and in gas turbines we can use the compressed air energy storage system. So this is not this is the very common practice we are doing in different field with the different applications. So first is the pump storage. You know, the pump is in hydropower station. We are storing the water at one place. This is called the dam, and from whole, you can say, year you are utilizing the water with the a proper head. You are passing the your some amount of the water with some nozzle, or you can say penstock pipeline to the your turbine section, and continuously you are utilizing the power, producing the power in hydropower station. And after the tailrace of the your water goes for the irrigation and other purpose. So this is called the pump storage. We are here, this is not applicable because we are discussing the solar energy. Second, flywheel this is a very common practice we are using uh, as a storage device in the automobile vehicle. When your energy is, you can say, normal energy is required, then you stored the flywheel stored the energy, and when needs the you can say energy required, then this will provide as per the requirement in automobile. Battery, this is a very common photovoltaic cell. Automobile vehicles also we are using as a storage device. Regenerative fuel storage, a hydrogen cell also, this is a very common uh, name. So electrochemical cell that converts the source fuel from the consumable substance such as hydrogen or methane in electric current form. So this is a uh, compressed air energy storage. So electricity you are using for you can say run the your air compressor, then air compressor uh, pass to the air turbine, then air turbine.
Hello. Hello, Satish sir. I am audible. Some network problem is there.
Sir, audible, sir.
Our expert.
Audible,
Abhishek.
sir.
Hello. Hello, Abhishek. Something happening with network with our expert. Just time call.
अभिषेक को 86 वाला पे कॉल करना
some network issue with our technical expert. He rejoin us.
Yes, sir. Hello, sir.
Yeah, Abhishek.
Yes, sir.
Some network issue with our expert, so he rejoined. No, Professor Abbas, no voice. So yes, no voice. Actually, our expert have some network issue. He rejoin us, and then again he start his presentation. Hello, Satish sir.
So Satish sir have joined, but like audio is not audible, sir.
हो गया आ गया बोल रहा हूँ
Yes, sir. Voice is visible, audible, sir.
Sorry.
Sir, please reshare your PPT, sir.
Okay, okay, okay.
Again share.
Okay, okay, okay. Oh, again say. This is visible, sir?
Yes, sir.
Yes, sir.
Yes,
It's
sir.
visible,
Visible.
sir.
Okay, okay, okay. Sorry, sorry for disturbance. Okay. So type of energy storage system. So in sensible heat storage system, we are storing the heat by using the simple principle MCP delta T. Amount of heat absorbed by the body, we are calculating heat gain by the body, we are calculating by this simple energy equation. Then latent heat, you know, when phase change uh, solid to liquid or liquid to vapor, no? So either melting the substance or solidified the substance, then in both cases we are getting the energy. So melting, in melting, you know, the increasing energy, and this is the decreasing energy in the form of storage system. So we are using the some phase change material. We have for acting for the latent heat, you can say principle. So this is the simple curve of the temperature versus the entropy, or you can say enthalpy. So this is the sensible energy gain, and at the fixed temperature, this is a saturation temperature, and you are getting the latent heat. Again, you are getting the sensible heat. So different type of the phase change material we are using as a latent heat storage material. So this can be classifying as, you can say, organic PCM material, inorganic PCM material, or eutectic type of the PCM material. So in organic PCM material, phase change material, paraffin is the very common material we are utilizing for the solar flat plate collector application. So this is the one is the paraffin wax type of the PCM material. Second is called, you can say that non-paraffin type of the PCM type of the material. In inorganic PCM category, we are utilizing the some salt, hydrate, or metallic type of the PCM material uh, for utilization of the getting the energy. Eutectic, you can say combination, either two organic material you are taking, or two inorganic, or one inorganic and organic combination. So depends upon our application, our field of the work, we are utilizing the different type of the phase change material. So here we are using the paraffin type of the paraffin materials, because this is a very safe, reliable also, and having cheap, non-corrosive in the nature, and having very high latent heat. This is very important. High latent heat capability with low conductivity. And and this is suitable up to 500 degrees Celsius temperature, shows the stable performance. So this is about the classification of the phase change material and application of the solar thermal system. As you know, the photovoltaic cells, in solar thermal stations, high temperature applications, parabolic truck collector, parabolic dish. So in solar air heating or solar cookers also, we are using the thermal system. I will discuss in the last how we can this system utilize for the solar cooker and other applications. So based on that, this is the basic, you can say basic uh, discussion characteristics of the phase change solar, you can say thermal storage system, phase change material, as well as the solar collector. Based on the our applications, sorry, in the, you can say, many applications we are using solar flat plate collector as and the solar thermal systems also. In agriculture works, you can say different uh, seeds and different variant of the foods storage for the storage purpose. Nowadays, solar heating and solar cooling system is the very common name. And so solar pasteurization is the application for the dairy plants in rural areas. We are using, you can say, the solar thermal storage systems. Uh, so solar pasteurization system is essentially for the killing of the bacteria present in the milk. So direct method which can be used for obtaining the, you can say, pasteurization temperature by use of the solar energy. So this will help to kill the, you can say, bacteria presence in the milk. So minimum and maximum temperature we are keeping 63 to 78, 80, approximately 80 degrees Celsius. So by using the very small capacity of the solar plate collector with approximately 1.2 meter area, we can very easily obtain the pasteurization temperature in within 20 minutes, 3 to 19 minutes, depends upon the available solar intensity, you can say. Uh, in depends upon the season. Normal in, you can say, March and April, very easily within 15 minutes or 20 minutes you will get the saturation temperature. So this is the application of the solar thermal systems. So how we can improve this PCM phase change material by using the nanoparticle. So as you know, by using the nanoparticle, we can increase the latent heat capacity of the substance. Thermal conductivity we can improve. Shape stability we can get by addition of the nanoparticle, and the transmission capability also get. So nowadays various type of the nanoparticles are available. So uh, uh, available to, you can say, which can be utilized to improve the performance of the PCM thermal storage system by utilizing a very small percentage. So but the second thing is, when you are adding the nanoparticle, then some property is increasing. In parallel, some other property may be decrease, influence the other properties also. So as a researcher, our work is to uh, investigate the effect of the, you can say, optimum percentage of the nanoparticle, which can improve the your thermal energy storage system performance, as well as, you can say, minimize the other property with, you can say, minimization of the other properties also, other effect also, side effect also. So this is the very small summary of the heat transfer studies of the solar thermal system integrated with the PCM. So maximum author has used the flat plate collectors. Some use the solar domestic hot water also, and just you see, this is the by ATAL 2018 use the thermal storage heating units. And PCM they have used, suppose 2010 used the paraffin wax, melting temperature is 70 to 80 degrees Celsius, and other has used the melting up to 36 to 38 degrees Celsius temperature, slurry PCM type of the, and Deng et al. Has used the PCM material set, sodium acetate trihydrate, as a PCM material, and this work up to 58 degrees Celsius. So maximum author have used the paraffin very successfully. So we have utilized the paraffin as a, you can say, PCM material for the experimental performance, and these are the finding: highest heat transfer performance and melting rate we are getting by using the paraffin type of the PCM material. So this is the one small summary how we can use the PCM material and improve the performance of our thermal storage system. So this is the some author have use the paraffin by using the some nano, you can say, paraffin materials, by using the nanoparticle, and just you see this is the effect of the here copper material they have used in the volumetric concentration of weight concentration of 0.5, 1%, 1.5 and 2%, and initial thermal conductivity of the paraffin wax are the 0.191, and after addition with this, you can say, percentage, and getting the improved thermal conductivity is approximately 28%. So uh, approximately you can say 40%, 50% 50%, approximate 50% increment of the thermal conductivity you are getting by addition of the nanoparticle in the your PCM material. Similar in other second case, 0.25 you are getting for 1.6. If you calculate, approximately 40% you will get. So PCM selection, either you can say, select by you doing the proper literature review, a recent literature review based on the your applications, and you can make the one table what initial value of the our you can say different properties of different thermal conductivity and different other properties initial value are you are getting, and by addition of the different percentage how much gain you are getting. So with the you can say, so making the summary chart, you can get the conclusion which type of the our for our application which type of the nanoparticle is suitable, and which type of the PCM material also suitable. So this is, you can say, this is the one selection criteria is the of the you can decide by corrective literature review, or you can perform the experimentation by giving the industrial data or any other data is available. So flat plate collectors can be heated from different angle. You know the flat plate collectors applications. So flat plate collector we can say very cheaply utilized for storing the thermal energy coming from the sun and absorb ambient heat and operate in the with the clear light. So this in there are the several parameters related to the thermal performance of the solar collector. This include the distance between the pipe tube, different you can say position of the collector plate, inclination, also collector plate cover, coating of the material, properties of the you can say tube material, properties of the polishing material, diameter of the your pipe, flow velocity of the your either you are using air or liquid, intensity of the incidence, radiation. So these are the things, thickness of the insulation of the bottom and different sides. So this property affect the performance of the solar plate collector. So new technologies have been used for many years to improve the thermal efficiency of the solar collector. This increase the absorption of the absorber plate, improve the heat transfer area, also stabilize the heat transfer fluid, and improve the geometry of the solar collectors based on the price, weight, and easy to maintain. So this is the flat plate solar collector. Simply we are utilize here for the experimentation purpose. So this is the solar flat plate collector. I will discuss later also. Use, this is a solar power meter, directly you can say measure the solar power. This is the your cooling section, and then here you can measure the flow rate of the your fluid flowing. This is the reservoir tank, and you can drain out. And this is the pump. Again, you can say pump the your fluid in your the solar plate collector. So new technology have been used for many years to improve the thermal efficiency of the solar collector. This increase the absorption of the absorber plate, improve the heat transfer area, stabilize the heat transfer fluid, and improve the geometry of the solar heat collector based on the price, weight, and other things. So this is the again summary. We have already, I think, discussed for utilization of the PCM. This slide we have already discussed. This is the experimental setup which we are using. हाँ सर, नहीं सॉरी, कुछ काम था. Using for experimental evaluation of the experimental performance. This is the solar collector, and this is the incidence angle modifier, and this is connected with the data logger data system, and this totally regulate with the one heater and one chiller. We are by using the solar simulator. So intensity of the radiation we are governed here by the intensity regulator. So this apparatus is consist of the solar collector, this centrifugal water pump of the 500 watt capacity, run the collector under the forced convection mode. Heater and chillers are also having with maintaining the working fluid temperature, and by this we are collecting the thermal and thermal efficiency and energy efficiency. By using this we can calculate. Rotometer is utilized for measurement of the flow rate, and flow rate here varies from 0.25 25 liter per minute to 5 liter per minute. So maximum power capacity of the simulator is a regulating knob that can be varies from 500 to 4000 watt. So here we are using the helium based power supply device, which we can continuously monitor the experimental performance of the collector. So this is the diagram of the experimental setup of existing setup. So this is the solar plate collector. This is connected with the rotometer, and this is a solenoid valve. This comes with the heater and then chiller maintained with the, and again by using the pumping you are repeating the same things. Total collector area is approximately 53.2 into, this is the dimension of the collector occupied volume, and absorption area is 0.230 meter. These are the specification of the experimental setup of the collector. So in the current work, we have used the different configuration of the absorber plate and tube channel. Just you see, this is a copper tube cuttings, and this is another operation. We are assembling the copper tubes as a observer plate, absorber plate. So this is the different configuration of the absorber plate. First, we have considered for analyze the thermal performance of the solar plate collector. So first one is the A is the circular absorber plate we have considered. In the B case, trapezoidal type of the absorber plate we have considered. In the C, we have taken this is the assemble part of the circular flat plate collector, and this is the assemble part of the trapezoidal type of the absorber plate collector. So this is a pictorial view of the absorber plate. Then first, before you can say analyze the performance of the our systems, first we have validated the our you can say data with the experimental available performance literature. So this is a global thermal efficiency calculation formulation. I'm not going in detail of the parameters due to time limit. So with this efficiency variation, with plotted with the reduced temperature calculated TFI minus TA by I. This is called the reduced temperature for water. We have calculated the global thermal efficiency, and these are the experimental curve, and these are the as per the governing equation curve with the reduced temperature, and approximately found the you can say shows the very you can say under limit of the performance of the experimental setup. So this is the validation of the experimental part. Then you know the thermal performance of the in you can say heat storage system is Q is equal to simple formula MCP delta T. Overall transfer coefficient, how you can calculate, you know, Q upon Q is equal to UA delta T. You know, U is the overall heat transfer coefficient. Here the overall loss coefficient is the function of you can say top loss coefficient, bottom loss coefficient, and and side loss coefficient also. So combinedly is called the U over all heat transfer coefficient. And this is the formulation of the mean temperature difference, log mean temperature difference. You know the T1 minus T2 by ln T1 by T2. So this is the formulation. Another inbuilt calculation I am not here discuss. Directly I am going to discuss the different thermal performance parameters. So first is the flat plate solar collector performance. This is the global thermal efficiency. Global thermal efficiency is determined, you can say, with the help of the top losses, bottom losses, and side losses, overall heat transfer coefficient. And this global thermal efficiency we have calculated for the three type of the absorber configuration. One is called the circular collector, second is the trapezoidal collector, and first one is the flat collector, conventional, which we have used. So black one is the global thermal efficiency curve with the flat plate collector. Red one is the circular flat plate collector, and this is the trapezoidal collector performance. And this is the linear fit with the flat plate collector and circular flat plate collector and trapezoidal. So global thermal efficiency for all the three type of the solar plate collector are design evaluated linear relations between the efficiency and reduced temperature. Reduced temperature is same Tf minus T2 by I. We have computed and varies from 0.015 to 0.035. So establish the solar thermal performance within the standard norms. So this is the curve we have calculated at the irradiance at 800 watt per meter square. Then this is the flat plate collector efficiency variation with the mass flow rate. In this case, mass flow rate our varies from 0.5 liter per minute to 2.5 liter per minute. So again, black one is the you can say efficiency with the our flat plate. Red one is with the efficiency with the our circular type of the configuration, and this green one is the with the trapezoidal type of the configuration. So, and this is the curve we have obtained. No, sorry. This is the solar variation for 400 to we have varies from 349 to approximate 1165 watt irradiance. This is the curve with the different irradiance condition with mass flow rate. So observation is with mass flow rate. When the mass flow rate increases, then your thermal efficiency with all irradiance condition is increases up to some level. Suppose here up to 1.5, and between 1.5 and 1.9 or 1.8 this will become stable. Then after that this will decreases. So it reflects the graph that solar intensity varies, efficiency increases, but the mass flow rate, there is an optimum flow rate. Beyond that efficiency decline due to increases the, because when you are increasing the mass flow rate, then irreversibility in the flow pattern is increases, and pressure loss increases, and frictional losses also you are getting. So efficiency, final efficiency you decrease. So this is the curve discussion with the flat plate collector efficiency with mass flow rate. Then this is the efficiency versus mass flow rate for a circular type of the configuration. So this is the same way. Here also this is the curve with the intensity varies from 349 to 1165. Here pattern is similar to the previous one efficiency, but circular configurations flat plate collector is getting the better efficiency than the our flat plate collector, and enhance the efficiency we are getting approximately 8.74 as compared to the rectangular flat plate collector. So this is the again performance with the trapezoidal surface type of the collector. So performance of the trapezoidal surface groove collector is best among all the threes. If you are comparing with the flat plate, circular, due to the enhancement surface contact area, because in trapezoidal type of the case geometry you are getting the more contact area, and with the your you can say flow pattern collector tube, so more conductive heat transfer will take place and more heat transfer you are getting, so efficiency is higher than as compared to the circular as well as the initial flat plate. So this is the 3D graph of the comparative visualization of the performance of the conventional flat plate collector, circular, and the groove type of the flat plate collector. So it can be noted that the version of the trapezoidal groove absorber plate performance reached the highest compared to the flat and the circular groove surfaces of the absorber plate. Percentage of the enhancement in thermal efficiency you are getting 8.74% with compared to the flat plate, and the 12.85% respectively with compared to the flat plate in the case of circular as well as the trapezoidal surface type of the cases. So this is the variation of the entropy generation. This is the 3D graph for the different all the three cases. This one is the flat plate collector and green one is the circular collector. Just 1 minute. Yeah. So this is the 3D graph. This is the mass flow rate. This is the solar irradiations, and this is the entropy generation. So entropy generation is the function of outlet temperature of the fluid and mass flow rate both. When intensity increases, outlet temperature increases, so that the entropy of the, you can say, total fluid is increases with intensity of the mass flow rate. So exergy efficiency is more appropriate. Second one is the exergy efficiency. So exergy efficiency, as you know, we are calculating with the, you can say, help of the second law of the thermodynamics. So exergy efficiency you can define by the actual useful heat to the total available capability of the your work. So exergy efficiency is the more appropriate parameter to define a system capacity to convert available energy into the valuable work. For solar thermal collector, this is a useful work can be measured by the thermal energy carried away from the flowing working fluid, storing in the heater as well as the chiller component. So exergy efficiency continues, just you see in this graph, exergy efficiency is continuously decreases with the solar intensity and the mass flow rate, because when your entropy is increases, then the losses will increases, you can say. So with the increase of the entropy, exergy efficiency decreases because you are some amount of the, you can say, irreversibility you are getting due to some you can say extent of the your irreversibility, your entropy generated. That's why exergy efficiency decreases. So under optimum conditions we are getting for the solar intensity of the approximate 1000 watt per meter square with mass flow rate 1.5 liter per minute. Trapezoidal absorber plate is the highest exergy efficiency we are getting. The next factor is the heat removal factor, is a very important parameter. This heat removal factor capacity of the collector is to utilize the heat available inside the collector to carry away the fluid flowing in the tubes. So just you see, this is a intensity varies from 350 to approximately 1156, and this is the heat removal factor. So by this is the data for the all the three type of the configurer flat plate and the circular plate as well as the trapezoidal type of the plate collector at 2.25 liter per second. So here this is the observation that when our intensity is increases, then the heat removal factor is increases up to some extent, increases up to, and after reaching the, you can say, maximum point, highest point, then again this will decreases. So here it increase the intensity up to optimum range. So here you are getting approximately here this 800, this is 900, this is 1000. So within 900 to 1000, approximately you can say approximately he 900 to 1000 watt per meter square, you are getting the stable range. After that your efficiencies increases, sorry, decreases. So here maximum heat removal factor you are getting for the trapezoidal case, red one is approximately 0.70, proceeds with the circular is 0.675, and for the flat plate observer you are getting 0.665. So highest heat removal factor you are getting in the case of again trapezoidal type of the flat plate collector. So here this is the overall heat transfer loss coefficient at the different, this is the you can say variation with the intensity at 2.25 liter per second with the different type of the flat plate as well as the circular as well as the trapezoidal type of the collector. So controlling losses is very important factor to minimize, optimize the collector performance. These losses are radiation from the top surface and the conduction from the side. You know, the top, bottom, and side. Three type of the losses we are uh, considering for calculating the overall heat transfer loss coefficient. So intensity is again when the your intensity is increases, then overall heat loss coefficient is fast decreases. Yes, you see up to 1000, then again increases. So loss heat factor decreases with the rise of the intensity and reaches the optimum lowest values, then again rise due to disproportionate increase in the radiation and conduction component of the losses. Performance of the trapezoidal is best as compared to the other. In both graph we can see. So this is the last curve for the thermal efficiency performance with variation of the Reynolds number. So at with the help of the mass flow rate, we have calculated the Reynolds number, and here Reynolds number varies from 500 to 3000. So approximately our fluid flow regime follow the laminar regions, and here in the laminar region with the variation of the Reynolds number, this is the efficiency curve of the flat plate collector, and this is the circular plate collector, and this is a trapezoidal flat plate collector. So in the case of trapezoidal, we are getting approximately our efficiency is 60, you can say 60 to 64, 63. In the case of the circular flat plate collector, we are getting up to 59 to 60, 61, and very low efficiency we are getting in the case of flat plate collector, approximately sorry, 53 to 55% approximately. So this is the performance of the flat plate collector. Some extent work we have, total work we have not performed with the you can say PCM based and thermal and our nanoparticle mixing. We have just calculated the thermal conductivity and diffusivity performance. Just you see, this is a pure paraffin wax having the thermal conductivity, and this is the addition of the our carboxyl nanoparticle with the percentage of 25%, 0.25% in the volume, 0.5% in the volume, and with addition of 0.7, and finally 1%. So this is the enhancement of the thermal conductivity with the addition of the nanoparticle. So based on the our discussion, based on the experimental observation, it can be concluded that solar collector heat removal factor is the most important critical parameter in the collector performance. There are various methods to enhance the collector heat removal factor. In the present investigation, we have considered the surface modification, type of the design configuration. So we have taken the three type of the surfaces. One is the circular, flat plate, and trapezoidal type of the surfaces to perform the to investigate the solar performance of the collector, and observe that the in circular and the trapezoidal surface collector increases approximately 8.75% and 12.85% absorber plate as compared to the traditional flat plate absorber uh, collectors. Exergy efficiency also increases by 16.68 and 23.31% as compared to the flat plate collectors. Since the heat removal factor is enhanced, the total heat loss factor decreases with the circular configure and trapezoidal surfaces of the absorber plate. The observed decrease in overall heat loss coefficient of all two type of design has been found as 5.5% approximately and 9% respectively as compared to the flat plate. So it for the further investigation, we have used the trapezoidal type of the surface configuration for calculation of the heat transfer. So this is the layout. We have modified the existing solar plate collector with our trapezoidal type of the section. So this is the airflow channel. This is a glass cover. This is a PCM material. We are working on that PCM material, and with addition of the we will perform with the PCM material. Then we can go with the addition of the nanoparticle. So this is the total setup for the PCM. This is the PCM cylinder with the different display of the temperature and operating system of the pump, water supply, and flow meters also attached with these systems. So this is the modification and performance evolution of the flat plate collector discussion. And then we are working on related to the this topic, working on two, you can say, working area. One is how we can design the renewable energy system for the rural and remote area applications. So our work is to you can say move the conventional mode of the cooking system to the solar based, you can say, cooking system. So in rural area, as you know, firewoods and charcoals are used for the traditional cooking of the purpose and increase the carbon footprints. So this is the uh, novel approach we have used. We are working on that for that we can utilize the solar energy thermal storage system to operate our stored energy into the chulha, you can say solar chulha, and this will, you can say, use for the cooking purpose. So if having the small capacity, so this is enough for cooking the energy requirement for family having the 4 or 5 members, or you can use for the commercial applications also. So this is the a small diagram. This is the thermal storage systems. We can store the energy, then supply to the cooking stove, and again by using the float pump, you can say this is the solar power. So by solar power, you can store the energy and then you supply to the cooking stove, and this cooking uh, uh, you can use for the commercial purposes also, and for if your area and for small purposes you are using, then domestic purpose you can utilize. Very simple way. So proposed solution is completely solar energy based, and maintenance is very low, and you can save the 10-12 LPG cylinder annually by using this uh, 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 this type of the, you can say, solar chulha. Initial installation cost, you know, the government is giving the various type of the support for install the solar type of the systems. So this solution is environmental friendly, maintenance free, and longer lifespan, and by using that with the temperature of 80 to 180 degrees Celsius, you can make any type of the foods. So this is a one you can say part of the working. Second, this is a also we are working on one DST projects. So developing a hybrid energy system for zero energy building. So this is the totally utilization of the different form of energy. Here we have used with the solar plate collector, PV cells also, wind energy also, uh, fuel cells also. So this is a battery storage type of the systems. PV cells, wind rectifier, and with the help of a fuel cell, you can store the energy in the battery storage system, and you can operate the in your room or in your building different appliances governed by the electricity. Cooling and heating and other requirement you can fulfill by the this is the solar flat plate collector. This is connected with our solar thermal storage system, and some heating devices you can put by the solar thermal storage system. And again, this solar energy you can supply to the solar refrigeration system, solar absorber. And this solar absorber, you know, the able to produce the uh, low temperature effect. So by low temperature effect, cooling devices, you can, cooling applications, C1, C2, and C3 you can utilize. So this is the sort of presentation. So by using the zero hybrid energy system for the zero energy building, so by using this utilization of the renewable energy sources, we can develop a net zero building, you can say, consume of the building environment. and by using of the renewable thermal energy for the heating and cooling purposes, minimizing the CO2 emissions also. So this is the sort of the discussion. If you have any queries or discussion. Yeah, participants.
Yeah. Thank, thank you so much, sir. Dear participant, if any query related to this presentation, please ask.
I think no query from the participants.
Okay, thank you.
Okay. So now we conclude third session. So thank you so much, sir. So I am requesting to Abhishek MS. Please conclude the session.
Okay, sir. On behalf of all the coordinator, myself, and a participant, for sparing your time of your busy schedule to provide a valuable information for us, and they give a very brief and clear approach to the respective research area. Thank you, sir. Thank you for your time and for lecture. Thank you, sir.
Okay, thank you. Thank you.
So participant, thank you so much. So we meet our last day on 14th Jan 2022. So in that we have three session. In apart from that, one from the one in our first technical session is the from meditation. So 1 hour expert is there. So we meet tomorrow at same time in same platform. So thank you so much. And already I sent feedback from to you in chat box. Those who have not got the feedback, they chat me. Then I send you. Okay. So have a nice day to all of you. Thank you. Thank you everyone.
Thank you, sir.
Yes. Yes. Please.
Sir, actually, tomorrow we have a quiz, isn't it, sir? And what time when we have it, and how many questions will be there, and how to prepare it?
Yeah, I'm not done that question answer, but approx 25 to 30 question is there. Okay, and
Okay.
1 hour be there for for that 30 question, and MCQ question is MCQ type, and
Okay. So what time exam will
hello.
be there? What time the exam will be there, sir?
After after finishing the technical session, then we start the exam. Okay, examination for examination.
So tomorrow also we have three technical sessions, isn't it, sir?
Yeah, yeah, three technical session.
Okay. Thank you, sir. Thank you.
Three technical session, and one is apart from that, one for that meditation, and two for the our technical session.
Okay. Okay, sir. Okay. Thank you.
Thank you so much.
Everybody, please do fill the Google form before exiting. Like, please fill the Google form before 8 o'clock of the today, because like after 8 o'clock, the Google form will be closed for today's sessions.